Oh, 3. Are we live? Oh, look at that hat. What was that? I saw a fireman come through there. We're at the fire station. Well, I guess we come online. I'm Jake Wizard 4 talking.
I'm Kenny Luna.
There we go. Somebody's waving. Somebody's signing on. This is great. We're going to chat tonight. I guess I'm going to start this meeting off with the official ringing of the bells. Would that be all right, Kenny?
That would be wonderful.
Okay, you got to remember, this is 1951. It's Saturday morning, and half the kids in the United States have turned on their black and white TV sets. There's only 3 networks, right? NBC and CBS and ABC, and maybe a public prop, but there's about 2 or 3 stations on the air. 10:30 on Saturday morning. All the kids are waiting for this noise. Ready? That's NBC, which we are not affiliated with, by the way, but that was their call sign. And Mr. Wizard had a couple of these that they would play. They would ding it at the beginning of each show, so I thought I'd get it out and just ring it. I just saw a fireman. Is that Jacob's kid? It is. I saw that fireman image come up. Did you see the fireman?
No, he
Kenny?
didn't see that.
Oh, you didn't see that.
Screens.
Okay. There's a screen there with something, yeah.
It's me changing screens.
Are you changing screens? All right. I'm just getting used to this streaming thing. I'm a streaming novice. I'm nearly 76 years old, and this is my second stream in all those years. So anyway, I'd like to welcome all of the 3 of you who have signed on so far, and there's going to be more. I mean, the people are flocking. If you listen, stick your head out the window, you can hear the flutter of people in the airwaves coming to see the wizard.
You can hear the stampede, Jake.
The stampede, man. I mean, the ducks. Look at the ducks. They're separating in the sky. They don't know which way is north anymore. My gosh, they're lost. So everybody's streaming towards the wizardry, you know. So I'm Jake, Wizard 4, and I just want to introduce you to my dear friend Kenny Luna. Say hello, Kenny.
That's me.
Hey, how long have you been involved in science education, would you say?
Almost 30 years.
30 years?
Almost, yeah.
Almost 30 years, 3 decades.
Yeah, close
And
to it.
You can get therapy for it, you know?
You can. I'll bet they give you a discounted rate.
No. Well, yeah, and I bet you later on we'll ask you have you seen it change across the years?
Oh, I have seen changes.
Yeah, I've seen a lot of changes. So you're still a science teacher? Mm-hmm. That's great, man.
I teach mostly 7th grade this year.
Really?
And it's a lot of fun. I have a great partner, and I enjoy what I'm doing.
Well, that's great. Well, there's somebody said hello. I remember that name, that Remy Lynn. Oh, Remy Lynn signed on. And muscle, what is that? Carpete? Not muscle carpet. What's a muscle carpet? I'm making fun of your name, and I'm sure not meaning to. Is muscle carpe? Oh, 68. Well, whatever it is. He's smiling. Thank you. Oh, Carpat. He's laughing at me. Don't make fun of an old man. I'm doing the best I can. And those of you who have signed on, I'm so glad to see you here. As you can tell, we absolutely know just enough about doing this to mess it up quite well. But we're learning. So give me 3, 4, 5 years, we'll have this down. If I live that long, anyway. But I've been a chemistry wizard for, 64 was my first lecture, so all those years, about 6 years, I still have all 10 digits. I still have all 10 digits. Oh, great. My kids and I love your channel. Well, hello, kids. I'm glad to see you. We're going to do some experiments tonight. Oh, let me tell you. Yes, we are. We're going to do some. We are going to do some demonstrations. We'll have to have a little lesson about the difference between an experiment and a demonstration. There is a difference in there, Luna.
There is.
There is. Are you awake, Luna? How do we tell when you fall asleep? I mean, is there any sign? We know when you're awake. Kenny's here to keep me honest, and I've got a wit coming. Beckett's going to be here. He had a basketball game to finish up. He's in high school, I think, sophomore. He's playing basketball, and but he's a wizard in training, a wit. He'll be here in a little bit to talk. We've got a whole string of stuff to do tonight. Oh my gosh. We'll be here for a couple hours at least, maybe longer if people stay awake, or until I get hungry and get crabby. Then we have to leave because we're going to go over to Walt's and get a cheeseburger after this. You haven't been to Walt's, have you, Kenny?
I've never been to Walt's. There's
Oh,
no
Walt's
Walt's on Long Island.
Oh,
where
man, I mean, they do old-fashioned cheeseburgers, but they use real potatoes, French. Oh, it's just so good. I just can't stand it.
we got Five Guys by me. That's fantastic.
Oh, yeah. They're really good stuff. So let's see. Tonight's topic for my regular viewers and you've joined us, we're going to talk about fumes and vapors. Fumes and vapors. And you say, why that, Jake? Well, two reasons. Somebody asked me once, "What do you have kind of a theme for being a wizard?" I'm not an evil man or a magician at all. The wizard means wisest one is what it's supposed to mean anyway. And I have a. Can you put that up? That one. We're going to put up something here for you to read. Here we go.
Oh.
Yeah, sorry.
What are we on?
Oh, he doesn't know what we're doing. They're back there. He's got too many buttons to push. Somebody asked me the other day, "What is a wizard, Jake?" Yeah, there it is. Can you read it? What does it say? Can you read that, Luna?
Sure, I can read it. You want me to read it to you?
Yeah, read it to me. See what it says.
Says the wizards are a strange class of kindly something. My face is in the way. Impelled by an almost insane impulse to seek their pleasure among smoke and vapor, soot and flame, poisons and poverty. Yet among all these evils, they seem to live so sweetly that they may die if they would change places with even a king.
That's what it is. We live amidst smoke and vapors, which we really like, and we enjoy what we do. Being a young scientist, and we've done it my whole life, I enjoy it so much that I would not trade it for even being a king. It's so wonderful, to be a wizard, to be a scientist. Yeah. And I wanted to show you something. First thing I wanted to show everybody, can you zoom in on this, Cody? I have a bracelet that was passed on to me because I'm Wizard 4. And I don't get a hat or anything.
Cody, I have your focus.
Oh. Okay. We're going to get a camera shot of this.
That's better. Thank you.
I guess I don't want to put it right in front of my face. That's kind of gross.
I still have your focus.
I'll zip down there.
I'm going to go with it anyway.
There you go. There's a bracelet that I have that I'm Wizard 4, and this will be passed on to Wizard 5. And I don't know if you can see it, Kenny, but it's got some chemical elements, the symbol for some chemical elements on it. Cody's going to zoom in on it.
A little tough. I see the one for gold.
Yeah. Get closer
Platinum.
here. He's going to zoom in. He'll get a little closer here.
Yeah.
Yeah.
I see platinum. I see gold.
Okay.
I see nickel.
Right over here on this side is a platinum, PT,
Yep.
right? And that's what that is. That's made out of platinum. So that's pure platinum. The PT is. The next one is got a C with little diamonds in it, and that's pure carbon. Diamonds are pure carbon.
Yeah.
So there's platinum and carbon, and that was Wizard 1's Michael Faraday's platinum. And we got a sample of that, made that element. And then Dr. Allier, wizard number 2, had some absolutely pure diamonds. We made that was put on. And wizard 3, Don Herbert, got a piece of meteorite. Most meteorites are made out of nickel and iron. The metallic ones are. That was a piece of meteorite. And that was from wizard 3. And I'm wizard 4, so I put this on AU, and that's 24 karat gold. And the last one is an empty. It's empty because wizard 5, we don't know who he or she is yet. So I put nitrogen there, and we cut a hole in the bracelet in the shape of an N because it's filled with nitrogen. Aha, pretty good, huh?
Yeah, that was pretty clever.
So anyway, this gets passed on to the next wizard, wizard 5, whenever we find out who that is, or 5 and 6, it'll be passed on, hopefully. And when Don Herbert, Mr. Wizard 3, gave me this, he said, Jake, you got to be careful now. I said, why is that, Don? He said, because there's 4.5 ounces of pure gold in that thing. And I paid $35 an ounce for that gold. I don't know what gold is selling for now. Do you know?
It's a lot. It's not $35.
A lot more than $35 an ounce. I think it's about
I want to say like 1,500, but it's maybe more than that.
Oh no, yeah, it's up around. It's in the thousands. So there's probably $12,000 or $15,000 worth of gold there. That when Mr. Wizard paid for it, it was almost $250. I would put it on, but since we're going to be working with some chemicals and stuff tonight, I think I'll just stick it in my pocket. And sometime I'll get the staff out. The staff is what's going to knock you off the floor. I also have a staff that I got when I became Wizard 4. I don't even know what wizard I'm at. So tonight we're going to talk about vapors. And why do we want to talk about vapors, by the way? I don't know any idea. Other than it's mentioned in the sentence I showed you about what a wizard is. We like to live in vapors, supposedly. That was written in the year 16. Jacob, what year was that written?
Which one is that?
That thing you just put up? Did it say on there? 1669. Johann, what was his name? Johann Joachim Becher. Becher, the phlogistonist. Have you ever heard of what do you say that? Phlogistonist. Do you know what that is?
I have no clue.
You have no idea what that is?
Not a clue.
Yeah. Anybody know what phlogiston is? Phlogiston. Anybody know what phlogiston is? Phlogiston. Well, phlogiston, believe it or not, was what was written. Let me look at my notes. I looked it up by a German guy. Well, first Becker first came up with it. Johann Becher. He came up with the term, and he said phlogiston is one of the basic chemical element. A basic element, not chemical. They didn't have chemicals back then. Earth, air, fire, and water. And they thought phlogiston was an energy form that was inside of things that would burn. So a piece of wood that would burn is filled with phlogiston. And when you set it on fire, the phlogiston came out. And that's what all that energy was. And you believe that? And it wasn't until Lavoisier in the 1700s said, no, there isn't such a thing as phlogiston. And he discovered oxygen and talked about how things burned and stuff like that. But phlogiston was something that people thought existed. And when something burned, you were letting the phlogiston out. That's why it got warm. You could cook with it. And when the fire went out because the air around it got soaked up with phlogiston, and the fire wouldn't burn anymore. So it's an interesting thing to look up phlogiston. That was back before chemistry. Yeah. So that's one of the reasons I thought I'd mention vapors because it's in our motto thing. And the other thing is, where I live anyway, I started noticing there were stores being opened up, shops called vape shops. And I don't know anything much about that. Do you have vape shops around where you're at, Kenny?
Oh yeah, I got plenty of them.
Okay.
I don't frequent these places, but
I don't either, and I had never gone in there, and I didn't know anything about it, and I thought they kind of scared me, and I didn't necessarily want to know anything about it, you know? So I thought, you know, maybe young people, if those vape shops are going to be around, young people ought to at least know the nature of vapors. Not vapor, vapor. I don't know much about vapors, but I know something about vapors. I got to be careful how I say that, isn't that right? They'll think I'm trying to get kids to vape, you know. I'm not trying to at all. We had a whole session for 2 hours on vapors.
Yes.
That wouldn't go down too well, would it? No.
See a tribe of fourth graders marching down to the local vape shop.
Well, yeah. Well, what I would like to accomplish tonight is just to review some vape or activities so we can prepare something for young people, you know, either a set of activities or something that would just get the basic concept of what a vapor is seated well in their head. And that's all. No, it's not trying to do any grand chemistry or physics or anything like that. I just want to talk about vapors, what we know about vapors, and so I want to do 3 things tonight. I want to share data, facts and fictions about vapors, common experiences we've had with vapors. And any of you folks that are joining us, if you have any vapor experiences or something you want to know about a vapor, just chime in and let me know. We'll see if we can figure it out. Vapor. Now, what else are we going to do? Oh, I want to try to figure out science process skills that we can include with a vapor. How am I going to say it? I can't say vaping exercise. That's terrible. A vapor experience. What science process skills, you know, measuring, observing, predicting, can we include with these activities that I'm going to show you? And then finally, I hope we can leave with some questions, some unanswered questions about vapor that would make young people ponder. I don't want to give them the answer exactly. So that's what I'm going to try to do tonight, is those 3 things, is share some common knowledge about vapors and see how we can get young people to think about them. At least have a basic knowledge of what a vapor is. So I don't know where to start. Hey, you know, our most famous vaping, hang on, I got to watch out what I'm saying here. I don't vape. I did smoke. Did you ever smoke a pipe? Did you ever smoke a pipe when you were a kid? Kenny?
Did I what?
Did you ever smoke a pipe or a cigarette when you were a kid?
No. I smoked 1 cigarette when I was in college. Actually, when I was in high school, and I hated it. So I do not smoke cigarettes. I will have a cigar on a rare occasion with friends.
You know, my granddad gave me a cigarette. He said, "Try that," and I didn't work well. I didn't like it, but I sure like that cigarette lighter. Let me tell you.
Yeah, that's
I got all excited about that cigarette lighter. I didn't like the cigarettes, but the cigarette lighter I was fascinated. I'd take a cigarette lighter. I wouldn't do a cigarette. And I tried a pipe. So I had an uncle that smoked a pipe. Yeah, a pipe. And when he would light that pipe up, it smelled so good. It smelled like toast or something, you know. And then I put that pipe in my mouth and sucked on that thing, and I thought I was going to die.
Yeah, I was going to say.
Oh, it was terrible. It was like I put my mouth over a campfire and just sucked in, you know. Oh, I couldn't understand why he would want to. One of our, Sophia loves a lighter. Sweet. You're one of the family. I don't know. I've got, you know, I do have some Wizard 4 cigarette lighters. Can you believe that? I don't smoke. I don't encourage anybody to smoke, right? But believe it or not, do I have one in the drawer here? Hang on. I have a drawer. I have all these drawers under here that are keep stuff in. This is my incendium drawer. Do I have a? Oh, I do. Here's one. Ooh, baby. So we'll have to have these for prizes. Sophia said she loves. If you love that, you love that. You're gonna love this. I have a Wizard 4 cigarette lighter. Whoop! We have some of those, don't we, Cody?
We do.
We have a little contest or something. Give away some cigarettes. I don't know. I'm not encouraging anybody to smoke, but to have a. Oh, I got to put some fluid in there. This one's dry, but it sparks. There you go. But it's
we're not encouraging you to smoke, but we like to give out prizes, and the prizes will include
a cigarette lighter.
A lighter.
I know, but it's got Wizard 4 carved on it.
That just makes it cooler.
What makes it cooler? But then if the policeman stops you, what are you doing? You go, oh, Wizard 4. I'm doing some science here, you know.
Is that like one of those fancy cards I get from my brother?
Now tell me the truth. You want one of these, don't you? You want one of these.
Who, me?
Yeah.
Yeah, I'd love one.
I see. I know. Because when I was a kid, this is back in 1952, my grandfather would pop this thing out and we'd listen to that noise. It goes click. You strike that thing and then you snap it shut. Oh, put it in his pocket. Yeah, we've got to figure out a way to get some Wizard 4 lighters out. Put that on the list of to-do things. But I don't want you getting in trouble. We don't play with fire here. We learn, right? Are you there, Kenny?
Oh, I'm right here. I'm not
okay, just checking. Well, I can't tell if you're dozing off, because of the lag. Sometimes the lag, I don't know what's going on.
Oh, gotcha. Oh, no, I'm here, Jake.
You're getting there? Okay. So tonight, we are going to do a spectacular. Hey, do you have a picture of that flame tube, Jacob, when we did it in London? Can you throw that up there? Now, this is when we were in London at the Royal Institution, and before the show started, what I did there, we entertained the tube. You see that little fire dancing through the tube? Can you see that?
Yeah, I can see it.
We had a plastic tube filled with flammable gas, and it went through the audience pretty fast.
That was very cool, Jake.
That was a cool demo, right? And we've had over 100 million people look at that demo online.
Have they really?
119 million, I think the last time they told me, something like that. Of watching a fire go in a tube.
Yeah.
And a little bit of stuff. So I thought we would do something special tonight. And later on you will see it. Cody, would you show them what you guys spent the day doing?
That sounds fantastic.
Now I want you to see what's in the studio. Can you see what's there? Do you recognize what that is, Kenny?
Looks like tubes to me.
There are tubes. Is that 100 feet, Cody?
100 feet.
That's 100 feet of 1.25 and 1 inch plastic tubing, all one piece. And we've got it hanging from the truss up there.
Yeah.
And I'm going to fill that with an explosive gas later on.
I like that.
And the fire's going to run through. We've already established that the fire runs through the tubes.
Right.
The fire triangle, you need fuel, air, and heat. And the fuel, we put fuel and air in there, but there's no heat. So when we add the heat, the flame runs through there.
How does the flame not melt the tube, Jake? Is it just?
Well, it's not in one place long enough.
Right.
But the question is, and I'm talking to Remy, Sophia, Remy, and all these people that are watching, Muscle Man, I'm going to run it through that tube. Do you think that flame will go faster running uphill or coming down? Because it's all looped there. I'm going to set that fire off in that tube. I know it'll go up that high because we saw it, travel that. It'll go up and it'll come down the other side and go whoop, up and down. What do you think? Going to travel the same speed or faster, slower?
I don't know. It's a good question. I mean,
around here. And just the process of thinking about it. I don't care if you get the right answer. It's just the process of stopping, putting down your video game or cell phone and saying, is that fire going to go faster or slower? Or stay the same or not go at all? So after a while, we're gonna run that. But I just wanted to let you ponder on that a little bit, see what happens.
Yeah.
We're gonna see what else we're gonna do.
You're on the right side.
Oh, there's Beckett.
Hey.
Here's the wizard in training. Let's have an applause for Beckett. He's here. Hey, Beckett is here. Did you win or lose?
Huh?
Huh?
Oh, no, it was just
Okay, practice thing. Okay. There you go. Wire Beckett up. Beckett is a wit. He's a wizard in training. Have you learned to spell wit yet, Beckett?
I'm like 2/3 of the way there.
You are
W-I something.
close enough, man. Well, Beckett's going to help me tonight with some of these demonstrations we're going to do. We're going to run that fire up and down the tube. We're going to make a little miniature rocket. We are going to see liquid oxygen. Have you ever seen liquid oxygen? Kenny?
No, I've never seen liquid oxygen. I'm looking forward to it.
Have you seen liquid nitrogen?
Yeah, that I've seen. Yeah, that's cool too.
Yeah. Where in the
Dude,
world
so
would
there's
you get
so-
liquid oxygen? And why would you care? What's that got to do with vapors anyway? We're going to do that.
We're gonna find
And
out.
then I've got an explosive vapor called butane.
got?
Yeah, we're going to put butane in there. That's going to be. You ever heard of butane? You ever heard of butane?
Yeah, it's like what's in a torch, right?
Yeah, I guess it's right. It's in a torch. Well,
Yeah.
and we're going to mess around with some. Oh, we're going to dissect a vape. You know those things that you see some people sucking on, those vape things. I want to take one apart and see what's inside. I want to see what the big deal is about this vaping stuff. And then we're going to try to get around to, if we get around to it, dare I say this last one? Somebody wanted to know, since we're talking about vapors, what is the speed of a fart?
Fast.
Well, I mean,
I don't know what the speed is, Jake, but it's fast.
Well,
Depends.
that's the
if
whole
it's in my
thing.
classroom, it can be slow and deadly. You never know.
No, I'm sorry, but I have a cat that breaks wind occasionally, right? And he'll be all the way across the room. Phantom is the cat. And I'll hear that little pop, that little pit. Nothing to happen. But somehow it gets from there over to me. And then I said, well, how fast does it travel?
Must be pretty fast.
Have you ever noticed the smell? It comes,
Yeah. It wafts.
It wafts, and you go and say, how does it get here so fast? You know, the cat wasn't that powerful. Now, Kenny Luna, man, he could blow something across the room. He can blow a window open
Uh-oh.
if he just aims right. But the idea is, okay.
Someday I'll tell you a funny story, Jake.
I know. And then we're gonna talk about a historic item, and I'm gonna recommend a book and see and look at some of the stuff in the collection. That's what we're gonna do. So let's do a science demo first. I'm gonna take. Would you hold that?
Yeah, sure.
Don't lose my notes. Without my notes, I'm in big trouble. Put that on there.
Big trouble.
You're supposed to say yes, oh great wizard.
Yes, oh great wizard.
There you go. He's got it. I got to get rid of this thing. Would you set that over there somewhere? There you go. Get that, Jacob. I like doing all this stuff. So what would be a good demonstration? Okay. Do you want to bring over the ammonia and alcohol? I'm going to introduce you to a thing we have in the collection. Get started here. Okay, matter of fact, I see. Hey, how do we take that off? I'll just take this. Oh, look at that. I'll just take this off. How about that? Well, look at this. You've done this before, right? I'll get this out of the way. Okay. This device that we're seeing right here. Uh-oh. There, I'll do that right. I'll get this out of the way. Okay. Put that away. You see this stand, Kenny?
Yep, I see
This
it.
box right here.
Yeah.
On one side it says, I'll see if you can read. What does it say down there?
Princeton Chemistry Department.
That's right. And what's it say on the other side? What do you see there on the other side?
I can't see much. HA.
H.A. That's Hubert Allier. That was Wizard 2. And he made these things, and it's called an Allier stand. Whenever he would do a chemistry lecture, or where he traveled around the world, he went to 88 countries, and he would make these and leave them there when he went. And the whole idea was when he was talking to an audience, and the audience was loud and noisy and all that stuff, he would set his stuff right up here and turn on a light over it, and the light would come on, and the whole audience would go quiet when the light came on.
I need one of these in my classroom.
To the side so people could see him.
Huh? Yeah, to the
I
side.
think they also put it to the side so they could,
Oh, I could see, so they could see Jake. That was my technical director, what we call him, smartiest rectinimus, or smart something else. Anyway, this is called an Allier stand, and I have one. And it's one of our most precious items because it's been around the world, 88 countries, and he used this at the Brussels World's Fair in '57 and in '61. Wizard 2 was the soul of the American exhibit in Seattle at the World's Fair. And he used a stand, an old, crusty old stand like this to do science demonstrations on. So I'm going to do a classic science vapor. Are you ready for this?
Yeah.
Have you heard of the word vapor? I'm not talking about a vapor.
I was going to say we were talking about vape earlier.
Yeah, V-A-P-O-R. Mm-hmm. Not vapor like somebody sucking on to stuff,
Yeah.
right? Okay. Fumes and vapors. You know there's a difference between fume and vapor.
What is it?
Well, yeah. It says fumes and vapors. There must be a difference between a fume and a vapor. This is a vapor. We're going to make a vapor. And I've got some very concentrated ammonium hydroxide. That is mean stuff. And I've got some very concentrated hydrochloric acid. That's very mean. You got your goggles on?
Yeah.
Okay.
Yeah, you ain't kidding. That is mean.
That mean stuff.
Yeah.
And I'm breaking the laws of physics. A good safety, chemistry safety, is I'm setting here. You should never set down around these because you could spill it, and where's it going to land?
Yeah, in
In
your
your lap.
face.
Yeah, it's going to land on your legs or down your chair. So, but that's okay because I'm 75 years old and I have nothing to look forward to, so burn away, put it right there. Now this ammonium hydroxide, what's that formula?
NH4OH.
NH4. That's got nitrogen, one nitrogen, and how many hydrogens?
4.
4, and then one oxygen, yeah, 4. And then another hydrogen, NH4OH. You want to zoom in on that? There it is. Ammonium hydroxide. Now, it's got tape around here. Why would I have tape around the thing? Oh, gee, man, God. Hui, hui. Little pressure there. I got some tape wrapped around this thing. Why would they put tape around this thing?
Keep it sealed, Jake.
Yeah, keep it sealed. Why would I want to keep it sealed?
Well, I don't know. I mean,
It
it's
must
pretty
mean some
complex
serious stuff. I got to seal it. Not only do I put the lid on, I got that thing screwed on. I got tape around the lid. They call it sealing tape. The reason is that even when the lid is on, you say there's no way those molecules are going to get out, are they?
Nope.
Well, I'll tell you the truth. Atoms and molecules are so small, they can work their way down the slightest little place. And I always do this with kids. Here's a piece of paper. Mm-hmm. Here's a piece of tab of paper. Hold that up. How many atoms thick do you think that piece of paper is? Just ballpark.
Maybe 250.
250 atoms thick. If I laid them up like eggs or marbles, you'd think that if I lined up that many atoms, carbon atoms, say, for this, it'd be about, this paper is about 250 atoms thick.
Yeah.
Well, if I fold it in half and get double thick, that's 1 million atoms thick.
Wow.
I was pretty close.
Pretty close, 250 to half a million.
500,000.
But a piece of notebook paper is about 500,000 atoms thick. How big are those atoms, molecules? Little bitty suckers, they're just tiny. So that's why I seal that, because they can leak out. And I want to show you something. You watch his face. Now I'm opening this with my arms out. Yes. Because all I have to do is go like that. Are you feeling that yet?
Yeah, it didn't smell very good.
Are you getting a hit of it?
Mm-hmm.
It is mean stuff. I'm telling you. Oh, geez. Yeah. Yeah, it is very strong. So I just sent a vapor over to him. Because some of this evaporated. Say the word evaporate.
Evaporate.
Evapor. Say it real slow. Evaporate. Yeah. So I went from the ammonium hydroxide in here, started mixing with the air. A vapor is air that has something that has dissolved in it. And in this case, it's a good example of what it's like that a vapor, the ammonia in here is mixing with the air, kind of dissolving in the air, and they call it evaporation or vapor, whatever. I'm talking too much. Got to take a deep breath. Please, Jake, don't spill this. I'm going to pour a little bit in this little dish right here.
Yeah, no gloves either, Jake, by the way. No gloves. No gloves.
Yeah, I don't want. And that stuff, that'll clear the snot right out of your head. I'm telling you. I'm going to set that up there. Yeah, like that. Put the lid on there. Whee! Dang. That smells like my wife's cooking. Now I've got some. Do you see?
I'm sure Carla will be happy to hear that.
Now, do you see anything going on there? Cody's going to get a zoom on there. It's just sitting there. You see anything?
Not yet.
No, I don't see anything, Jake.
You see the liquid in there? Is that in there?
Mm-hmm.
Okay. I'm going to take this and put some hydrochloric acid in it. 6 molar. I wonder what that means, molar. Have you got any idea what molar means?
I'm guessing it's not about teeth.
Okay. Mm-hmm. We'll talk about that some other time, but I'm going to pour a little 6 molar acid in there. Okay. I'm going to set that over here. Now, I hope this works. This is a classic science demonstration. And this got a lot of people upset first time they saw it. They said, this can't be happening. Now, I've got 2 dishes there. I don't see anything going on. Do you see anything going on?
Not yet.
Okay, come on. I can sure smell that ammonia.
I think you ought to turn the light, Allier's lamp on.
Turn it on.
Oh, there it is.
Do you see something?
Oh, yeah.
What are you seeing?
Well, there's some vapor coming off.
We're going to try
Yeah,
to
I
light
can
it
see
up.
it here. I can
Oh,
see
we're
it
gonna
here
get-
too, Jake.
Did you see that vapor when it came up?
Uh-huh. It's still coming.
I see it again.
You see it again?
Yeah.
Yeah. Where's that coming from? I wonder if I've got some black paper down here. Let's see if I can put something up. This is why we call this experimenting. We have no idea what we're doing. So you've got some black down here.
Got some blue.
Do you see it coming up? Got something dark. Oh yeah, that's dark here. We got something dark. See if that makes it better.
Cody, I have your focus assist again.
Does that help any?
There you go, it's clean.
Does that help having the color on there? Can you see anything, Kenny?
No, I can't.
Okay, we'll try this one. There we go. Does that help?
I still don't see anything. Oh, now I do.
There we go.
You see it?
Yep.
All right.
Yep, I see a lot of vapor coming off, actually.
Yeah, okay.
The one on your right to my left.
Yeah. Can any of you folks that are watching say, oh, they said yay, they see it. Oh, that looks like a snake. Look at that thing. It's getting better, isn't it?
Mm-hmm.
Excuse me.
Yeah.
Yeah.
Cody, step all the way in. Your way in.
We're seeing a classic vapor. See if
Now,
I
why
can-
is it doing that, Jake? Why is it doing that? Is it because they're next to each other, or is it just we do it without them?
Oh, look at that. The fact that molecules are so small, things evaporate. They go into the chemicals go into the atmosphere, and we breathe them in all day long. And just because we can't see them doesn't mean they're not there, right? And there's all kinds of stuff in the air. There are all kinds of vapors, chemicals that evaporate, and we breathe them. That's kind of neat seeing that.
Yeah.
I'll get a little closer.
Well, what makes them do that, Jake? Like, what makes is it because of the two of them? are
Oh,
two
this
of them
one right here? Well, what's happening is both of these are evaporating. I'm getting some ammonia molecules going up in the sky. And I'm getting some hydrogen chloride going up, and they chemically react. There's a chemical reaction, and I'm making some, let's see, that would be ammonium chloride. That white stuff would be ammonium chloride. There's a chemical reaction taking place.
Yeah.
And it's the fact that I'm not doing anything, I'm not making this happen, it's doing it on its own. It's reacting to just the currents in the room. So this was my best example of this whole classic thing. It's not working too well. I don't know why.
Try walking.
Why? I think it's working fine, Jake. What else is it supposed to do?
Now this is all it does. Oh, look at that.
Fine. I was doing a good job of that. I was seeing a bunch of it.
Yeah. You've never seen this before?
No.
Hey, would you go over in that drawer over there? It says watch glasses. Can you see it anywhere over there? And see if we get. We're going to try pouring this out and make it spread out. You see a little drawer and see where is that? It says right there.
Oh yeah.
No, you see it says watch glasses. Yeah. Pull it out. See if you find some flat little dishes. We'll probably try pouring it in different dishes here. You got two. Yeah, that'll do it. I like experimenting like this. I've not done this, so let's see. Which one's the acid and which one's the ammonia? I don't know. Can you taste the difference?
I think the one on the left's the
Which one is this one? Oh, look at there. It's done something. So I'm going to pour. I'll pour the acid into this watch glass over here. I'm just going to try this. Okay, I need something to set this on. Let's see, where do I got? There we go. There we go. Set that down over here. Make note to self, do not spill the acid. Oh, there we go. Tray. Look at that. A tray. I take back what I was saying about him. Now here's the ammonia. I'll pour the ammonia in that and spread it out a little bit. I wonder if that'll help our efforts. Do you think?
Maybe.
Maybe, I don't know. Spread that out a little bit. If that does any better.
can see a little bit. There we go.
I definitely see it, Jake. I
What happens if we turn off the studio? Can you turn off the? Well, maybe we shouldn't. Yeah, try it again.
Oh, there we go. There's some
There,
like
there,
sitting
so
in
there,
the
they're
pan.
going. There they go. Yeah, now you can see it going. Yeah. Where's your black again? Let's try the black again. Right there. I can sure see it right here coming up on the top of it. Does that help? Okay. Well, anyway, maybe it doesn't. But oh yeah, man, come on. Whee! Well, whether you folks can see them or not, I can sure smell the vapors. Did we get a big enough view of that?
Yeah, we're good. Yes.
We're pretty good with that?
Yeah.
Okay. This smells like the world's dirtiest diaper, that ammonia. Wow.
What it smells like, huh?
Wow. Well, we made a vapor. Mm-hmm. Yes, we did. And I don't know how I'm going to do this. We'll just put this down here. Now it's making the fumes right under my nose.
Yep,
You know, you
right
set it
there.
down here.
Right there.
Right there, it's fuming like a son of a gun. And can you see that? Can you see it now? Wow. It's coming right towards me, isn't it? Look at the fumes. Are you getting those, Cody?
Yes, sir.
Okay, there it is. Hey, Cortland, you want to take this out? And don't feed it to the cat, though. I'll get in trouble again. Okay. So I guess we kind of proved that vapors exist, even though they're wispy. Here, I'll let you get that out of the way. I think, are we done with this? No, we're going to use this later. No, we're going to use this over there, aren't we?
Both.
Yeah. So where do we want to put it?
Over there for now.
Put it over here for now. Okay. And I'm going to give Cortland the, you want to taste this?
Maybe next time.
Next time, okay. There you go, I'll give those to Jacob. Those are mean things. Is that the first time you've seen that, Kenny?
Yeah. That's a cool experiment.
I think I probably would have done myself a favor if I'd have warmed those up a little bit, made them evaporate a little faster.
Yeah.
You know, that's a little trick of the trade to warm them up a little bit. So anyway, let's see, what's another one we can do? Oh, another vapor. Check this one out. Here we go. Now I'm going to take this candle. I'm going to put this candlestick up here. I want you to see it. I don't know. This is probably one of the most ancient or sacred, I don't know what, the honored pieces that we have in the studio, Kenny. It's I got it in London. I can't tell you how I got it. It was kind of a deal thing with a thing. But at the Royal Institution of Great Britain, they cleaned out and got rid of some stuff. And this is a candlestick holder that was used for years for demonstrations and such. It's really kind of cool. Can you see the coins in there? Can you read one of those coins?
It says Victoria de Gra Brit Regina
Yeah, Regina. That's the Queen of England.
Feed
Yeah,
Deaf in
yeah. He's reading it. What year does it say on there?
that one doesn't say one.
Does it say on that one? Can you read any?
1861.
1861, yeah. So this thing's pretty old, right? And they put some penny coins. Those are penny coins. Can you believe that?
Dang, that's a big penny.
That's a big penny, man. So I'm going to have you stand up and light that candle. Okay, let it burn a little bit. Is that up there too high? Do I need to bring it down?
Yeah, well, let's point out the coin one more time for Cody. Nobody got to see it on stream.
To do what?
Point out
Point
the
out
coin.
the coin one more
Okay.
time for Cody. Nobody
There you
got
go.
to see it on stream.
There you go. There's a coin. There's coins in there. Another one. Somebody put these pennies in there for decoration, I guess. And down here in the bottom, somebody put. Can you see what it says down there in the bottom?
R.I.
R.I. Let's see what. I guess they used tax. Right down there. You look at that, Cody. Get that. You see where my finger is?
Yeah. All right. Yeah.
There you go. All right. What does that RI stand for?
Royal Institution.
Royal Institution. Yeah, there it is. So we got this old ancient thing, and we got to wait for that to burn down a little bit more. I'll tell you what, I'm going to set this. Why don't you scoot that over there? Pull that towards you. That's a stand right there. And just pull that right. Get it right over there a little bit more. There we go. And you want to take that stand and pull it down. So the candle will be right about there. Now we're talking. Now we're talking, right? Okay. Now this is one of Faraday, when he did the lecture, Chemical History of a Candle, he did this activity over and over and over and over and over. And we've done it here over and over and over and over. Take some matches there. Get several there going, yeah, okay. I'll get several out here. Now, Faraday could make this work. He wanted to demonstrate the nature of a candle flame, that a candle is a vapor. But it also is a fume. Because inside that vaporous thing right there are some hard particles. They're clusters of carbon. And whenever you have a solid piece dissolved in the air or moved about it there, that's called a fume when it's a solid. When it's a liquid or a gas that's been dissolved, they call it a vapor. And, well, at least some people do. When you look up the definition online, what's the difference between a vapor and a fume? The fumes have solid particles in them, and I guess if you get down small enough, they're all particles. But
Yeah.
But this has this is a fume that has particles of carbon, and they're so hot they're glowing, right? So you're going to take your. Now you want to blow that out for me? I'll see if I can make the flame jump down the. Let's see how I do. Oh,
that was a good one. First shot.
First one. Did you see that?
Yeah.
Who's the wizard? I'll do that again.
Yeah, wizard, Jake.
Was that a good jump? Did
That
you see
was.
that, Kuna?
Yeah, I thought it was a good jump. A good
Yeah.
jump.
Have you done this before?
I can't remember. I think I must have.
Do this with your kids at school or something?
Yeah. Yeah, we've done this before. Yeah.
Well, the idea is, and so you could ask the kid, what does this demonstrate? Why would I even waste my time doing this?
Right.
You know, what is it? Well, it's not the wax that's burning. It's the,
The wick.
well, it's not even the wick. Well, the wick is burning a little bit, but it's the liquid. You know, you see the liquid gets sucked up in there.
Oh.
But then it gets sucked up, it rides up, and it vaporizes, makes a vapor, and that vapor ignites. So it's the gas that's burning. And when you blow on it, it still comes out. Oh, that was a through incher.
That is so cool. Never gets
Okay, let's go
old.
for a longer one. Come on. Go for it. What do you think? Come on, baby. Come on. You can do it. I waited too long. I spazzed out. Okay.
Yeah.
I got to build up my wax supply.
There you go.
We'll wait a second for that to build up some more wax, because you got to get enough wax built up in the wick. But I saw in one of the writings about Faraday's A Chemical History of the Candle, he could get the flame to jump 6 inches somehow. I don't know how he did it, but somehow he was,
He just practiced it, Jake.
he practiced, and I think it depends on the nature of the candle, because some candles are dripless, they don't want to be smoky,
Right.
and some candles are pretty crusty.
Yep.
And I think this is a handmade candle made out of I don't know what it's made out of. I don't think it's normal paraffin. Kind of not a dirty wax, but different candles will get better results. Some you can't barely get the flame to jump at all. But that's another. Do you want to do it?
Sure.
Okay, I'll try to blow it out. Is there another trick we need to know about this? Try to blow it out very quick, a very quick puff. Well, all right. Go stand in the corner, Whit. I'm telling you, that was pretty bad. That's terrible. I mean, God, that was. You got to practice this at least 300 times, I guess, to get it going. I don't know. We'll do it one more time. Wait a second. Wait, let it build up a little bit more. More juice, you know. I have one candle and I can't find it. I got it when we were visiting London at the gift shop at Westminster Abbey, and there were these big, fat, handmade candles with a big, fat wick, you know. And boy, the flame would really jump, you know, because you got a lot of smoke coming up when he blew it out.
Yeah.
You know. You got a match?
Yeah.
Okay, I'll blow it out again. You light your match. Ready? Oh, that was a good one. 2.5.
Yeah,
You beat the old man. This one time you beat the old man. That's very good.
Just once.
That's right. That's kind of a good vapor demonstration, wouldn't you say?
Yeah, I would.
Make you think about vapors? I don't know. What's anybody say? I can see it better now. Ammonia is a strong smell. Yes, it is. Put a little ammonia behind each ear before you go to the dance. I'm telling you, you'll pick up the strangest people. I'm going to have you move that.
Can we blow it out?
Yeah. I like the smell of that ammonia in the morning. There you go, Whit. And move that can over there too, would you?
Oh, this one?
Yeah, get whatever. I guess that was just put there to aggravate me. It was a candle stand anyway. Okay, I'll move back over here. Check our calendar and see what else we've got to do. So what do you think? You think we should fire up that tube yet, Jacob?
That's up to you and Ken and Beckett.
What do you think?
Well, what
I
else
think
you got on the agenda, Jake?
Or should we do liquid nitrogen? I don't know. I've either got to do liquid oxygen or fire up the tube. What do you want me to do, Kenny?
Let's do liquid oxygen and then we'll fire up the tube.
Liquid oxygen. The man wants to see liquid oxygen. Okay. It'll take one moment. Kenny, would you recite some poetry or something while I move this stuff off of here?
Poetry?
Or like a song?
A song or a are we done with? No, we're going to use that later, aren't we? That's right. Okay. Now we got to get some cotton over here too, don't you? Get some cotton? Yeah. Oh yeah, we need a smaller doer, don't we? You want to get one? Okay, this is great. Where is it? They're way up there.
Oh, maybe I don't got it.
Well, we can move the ladder over there, huh?
Beckett's tall.
Beckett's tall. Now move the steps over.
Where are they at?
You see right up there on the very top shelf, way up there.
Those metal things.
Can you make that all the way up there?
Hopefully.
Don't fall.
Oh, let's give that man a hand. He got up to the top shelf, got the doer down. That's great, Beckett. Thank you, sir.
Yep.
Okay. I like that. I saw a side of Beckett I've never seen before. That was kind of a joke there.
Oh.
Now you notice what's going on over there. He's got a big dewar. That big thing is called a dewar, D-E-W-A-R, of liquid nitrogen. And he's going to pull that over here. You want to go do it?
Sure.
Why don't you go put on those blue gloves over there? And I'm trying to train Beckett to be, a wizard in training, so he's got to learn all these skills.
Okay.
And
Yeah.
we went down to the welding supply store, Kenny, this morning, and got that's where we get our liquid nitrogen.
Gotcha. What makes them have it?
Well, they use it for when they put metal pieces together. They want to shrink one of them, to get a tight fit.
Oh, gotcha.
They'll chill a piece of metal. It will shrink down, and it will. Then they can put it in a hole, and then when it heats back up, it'll be really tight, and they'll weld it away. Oh yeah, I'll bring those over too.
That's a pretty cool way of doing things.
We got to do the full thing here. I have no idea what this has to do with liquid nitrogen. I have no idea. We'll find out later. Yes, we got cotton. We still have our, okay, we got it all here. So ladies and gentlemen, I know you breathe oxygen every day, don't you?
Yeah.
The air is what? Air is made of what?
Nitrogen.
And what's the ratio? Do you know?
3 to 1.
3 to 1? I think it's about, does anybody else know online? Liquid? Oxygen 3 to 1?
4 to 1.
4 to 1. There you go. About 80%. Unless you live where Kenny does, there's not much oxygen up there. They burn that. They burn it up there. They burn it up there, right?
They do.
Yeah. We breathe 20% oxygen and 80%, well, 78% nitrogen, and there's a bunch of other little things in there. And then all the pollution we bring in. And by the way, there's water vapor pressure, and that's one of the things we'll talk about later maybe, that when we inhale, besides oxygen and nitrogen, there's a lot of water vapor in the air. It's about, what is it? See, 14.7 pounds per square inch is air pressure at sea level, and 0.3 pounds per square inch is water vapor pressure, something like that. There's a lot of water vapor in the air.
Yeah, I've heard it's a very effective greenhouse gas too.
Yeah. Water vapor. So you breathe water vapor too, but we usually don't talk about that. Right? So in a minute, Becca is going to pour some liquid oxygen at minus 196 degrees. It's really cold. Huh?
Nitrogen.
Liquid, like I said, he's going to take liquid nitrogen. Did I say nitrogen? The first time I said oxygen, didn't I? I screwed up. Okay. Liquid nitrogen. I think it's about 196 below, something like that. He's going to pour it in this aluminum cup. And that aluminum cup is not very cold, it's not very hot, it's just room temperature. But compared to that, this is boiling hot, all right? So when he pours that in, it's going to boil because this thing is just like spitting on a hot griddle. But eventually this will chill down. This is just an aluminum cup that I got. We scoop things with. There it is, this aluminum cup. And have you ever had a glass of iced tea or a Coke or something?
Yeah.
What happens to the outside of the glass?
Water condensates on it.
Yeah. And that water's coming from the air, right?
Yeah.
Okay. We've all done that. We've seen the drips on the side. So we're going to put liquid oxygen, dang it. There we go, liquid nitrogen into the thing. It's going to get it down to minus 196. However, liquid oxygen liquefies at a slightly lower, I guess higher temperature, would be a lower number. I think it's 193 or 4 or something like that. I can't remember what it is. Have to look it up. But instead of sweating water like it would on a glass of iced tea, we will start to see some dewdrops on the outside of this. And those dewdrops are oxygen. And they will run down the outside, and eventually they'll start dripping off the bottom here. And we will see some liquid oxygen. Very rare. Don't get to see it very often, except here with Wizard 4. We're gonna see some liquid oxygen. So are you ready to do this?
Yeah.
Here we go. Now by the way, I don't want to aim that at you, do I?
No.
Because then we might shoot out. And so I tell you what we'll do. I will tip this back like that, and you can pour some liquid oxygen in there. There you go. That'll probably do it. Okay. I don't know how much you put on there, but if you put too much and it spills out, we'll know better.
Okay.
I'm going to tip this forward, and
All right, I'll let you know.
Is it going to spill out?
I don't think so.
I don't think so. Going down?
Yeah, you're good.
Getting ready to spill?
Nope.
Huh? Not going to spill yet? Okay.
We're good. It's pretty close, but
Pretty close, but we're good. So we're just going to sit here and wait. You think the outside of that thing's getting cold?
it looks like there's a little bit of frost forming
A
there.
little bit of frost. That is some water coming out, right? Uh-oh. It's starting to get sassy, is it?
Yep.
Okay.
Yep.
I tell you what, why don't you and Cortland pour another, no? Oh, hold on.
Oh, there we go.
Do you see something dripping?
Yeah.
Yep.
Do you see that drip?
Yep.
Cortland, do we have another one of those little dishes? We don't, do we?
Yep. I see
That
it.
little bitty thing you had? Either I've got a hole in the bottom of my cup or something's dripping off of there, right?
Want me to check the box?
There you go. Don't have any more of those things? Where they were? Well, get me another watch glass over here behind you. Get me a watch glass. There you go. Or Cortland's got one. Yeah, rinse that one out. That's cool. Perfect. It's dripping. We're going to collect ourselves some liquid oxygen. Probably crack the glass. I should have thought of this earlier. Sorry. You can tell how well organized we are here.
Jake, how long will it stay liquid before it evaporates?
Well, till it gets to the right temperature. It'll stay there for a long time, but it'll get warmed up. It depends how the atmospheric air is, you know.
Mm-hmm.
Isn't that cool?
Mm-hmm.
Yeah, it's very cool.
And I don't know if you can see it, if there's a color to it or not.
I can't see it on the live stream.
Yeah,
It looks almost cloudy to me.
yeah. Can you see through the cloud? Can you see the glob? Oh, yeah.
I see the glob, but the glob itself looks like whitish.
Yeah, white. Sometimes it'll have a tinge of blue. Yeah. Is it still dripping?
A little bit.
Okay. So I'm going to try this thing. It's probably the dumbest thing I've done today. Let's see. Get a pair of pliers here. Oh, you got tweezers. Man, this guy's thinking ahead. This isn't the dumbest thing I've ever done, but
Well, that's probably good.
huh?
So that's probably good.
What I want you to take, where's the matches at? Right here. We'll stay back over here a ways. Here you go. I'm going to take this piece of cotton and light it, and I'm going to blow it out. And then I'm going to stick it under the drip of liquid oxygen. I wonder what it's going to do.
Good question.
Oh. Okay. You light that? All right, you just hold still. You know. Okay. Is it still glowing anywhere? Let's light it again. Come on. Okay, I'll let it burn just a little bit longer to get some coals. Okay. Yeah.
Whoa.
Can you see that?
It's reigniting.
I'm going to stick this in there. Ready? Here we go.
Yep.
Let's see. Is it dripping? Now, did it quit dripping on me?
Might have quit dripping.
Well,
Nope,
on.
just go drip.
come on. Is it running low?
I got more nitrogen in the
Yeah, it's low.
dewar.
Oh, okay. Hang on. Here we go. Going to dump it in there?
Yep.
Okay. Okay. There we go. We'll get it dripping again.
You want me to light it again?
Yeah, light it up. Oh, yeah, now it's going. Let me see. I still got some smoke here.
Dewar.
Okay. That's right. Move that out of the way. Yep. You want to light it up again?
Yeah.
Are we having fun with vapors?
I am.
Yeah, I am.
Okay. Oh, there's a little oxygen left on there. Get that, huh? Okay. Okay, here we go.
Oh, a
Yeah.
little bit of sparking.
A little bit of sparking. Ow! Bombard with the liquid oxygen. Boom. Boom. Isn't that cool?
Mm-hmm.
Boom.
Got a
Boom.
nice little stream going now.
That's what I'm saying. Of course, the heat from the fire is going to make it stop sweat, you know.
Yeah. Almost out of cotton.
Almost out of cotton.
That's great,
Kenny,
Jake.
you're
What a
seeing
great-
liquid oxygen dripping on a flame. What are you thinking?
Yeah, what a great demonstration.
Well, it's what we do.
We should burn a Cheeto.
Oh, no. Burn a Cheeto. Speaking of Cheetos. Well, now you did get to see, I mean, what else can I do for you on a Monday night? I showed you liquid oxygen. That's pretty cool, isn't it?
Yeah, I agree.
Yeah. I like it. Somebody said, ooh, look at that. Whoever said that, I just love you to death. Ooh, look at that. I usually get that when I'm walking down the sidewalk. People go, ooh, don't look at that. They say, look at that. That's great. So I don't know. Is there any liquid nitrogen left in
We've
there?
got some in here.
Yeah. Okay. Good. Oh, we got a little bit. Pour some more in there. Want to pour some more in there? I don't know about this. They dared me to do it. I'm just dumb enough. Okay. So tell me what is, Cortland, you did this, right?
Yeah.
So how do I do it?
Put the Cheeto in there.
One at a time?
Or how many you want.
Okay. And then what do you do?
Put your mouth.
I put the Cheetos in the liquid nitrogen and then put them in my mouth. I guess I'll have to do it because I can't do it to the wit.
I don't feel like eating a liquid nitrogen Cheeto today.
So I'm going to take the Cheeto and throw it in there.
It really promises.
Yeah, put some more. Yeah. Just throw them in there. Grab some, throw them in there. 2 or 3 more. Okay. Now hold them down. Are you submerging them? Now what am I supposed to do?
Take the tongs, take one out.
Take the tongs, take one out, and do what with it?
Line your teeth. Take a bite.
Okay, here we go. Well, that's funny. That's really weird. All right, chew on it. Oh, that's kind of nice. Kind of tasty. Whoo, 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 whoo. I don't feel a thing. Oh, my tongue fell off.
Uh-oh.
Hey, I feel like a vapor.
A vapor.
Is there another one in there?
There are a lot more in there.
Oh, let's go. I get a snack. Man, that's something. I thought I was getting kind of afraid to do that. It messed me up in any way, shape, or form. I'm just doing fine with it now.
Whoa,
Okay,
whoa,
that's
fumble,
right. Fumble, I'll get it.
Okay.
Yeah, I get it. Put it in my mouth.
Oh.
Or on my teeth. Hooey, hooey, hooey. I'm chewing on the thing. If my mama could see me now. You know, what are you doing, son? Well,
Vaping a Cheeto.
come here, little girl. That's going to scare my granddaughters, isn't it? I better not do that. What do you think, Kenny?
Yeah, scaring your granddaughter is never a good thing.
That was not a good thing to do.
Nope.
I'm ashamed of myself. That would scare somebody to death. I'd probably have to send them to therapy after that, wouldn't I?
Uh-oh.
Grandpa did that. But we'll not do that. Disregard what I just put up on the screen. That did not happen. I will deny all existence of the thing with this stuff. Those are pretty good that way. You want to try it?
Share with the rest of us? Are you going to share?
Oh, you gonna share? Let's go. Come on, we got plenty. There we go. Yeah, baby.
I'll have to get my own.
Yeah, get your own. He's going to get one in there. Turn around the camera there, Jacob.
I gotta get a hold of it.
Yeah, I know. There. Pinch it in your teeth.
Careful. Jacob the Vapor.
It's not your nose.
That's right your nose. That's what I'm saying, man. I'm telling you.
It's good?
Go for it, Cortland. This is the dumbest thing I've ever seen. Oh, yeah, there you go. That's good. That's good. That's really good. That's really good.
Does it taste any different than a normal Cheeto?
It very faintly. It's a fainter. You can still taste the cheese.
Right.
And the question is, I don't recommend it, of course, because it could get in your eye or something like that. But why am I not burnt in my mouth? No, frostbite or whatever.
Well, because it's vaporizing so quickly, I don't think it has
does.
time to.
It makes what's called a Crookes layer. It's a layer of gas. The same thing that causes that oxygen to skittle around on the glass, you know what it's doing?
Yeah.
There was, the oxygen landed on the glass and there was enough heat there to make it boil. You get a thin layer of gas and it skittles around.
Jake, somebody in the comments asked, like, what's the difference between freeze-dried Cheetos and that kind of Cheeto?
Well, they were freeze-dried.
Were they freeze
Well,
dried?
I don't guess they were dried. They were just frozen. I don't know. Freeze-dried would mean you're taking the moisture out. You know, you freeze it and then suck it off somehow, vacuum it out. Freeze-dry something. We just do it because it gets smoke to come out their nose. You know, that's the main reason we do it. I'd just rather eat the Cheetos or cheese puffs. But anyway, we got to entertain the troops. You know.
Yep.
But there is up to a point. There's an old science demonstration, but I will never do it, where a guy stuck his hand in molten lead.
Oh.
Molten lead.
Molten lead. If you look it up, I think maybe he did it on a Tonight Show or something. David Letterman or somebody, but there is the moisture on your hand will provide a thin layer of steam. They call it a Crookes layer. It's what makes things skittle around on a hot iron. When you spit on an iron, it skittles, that layer of gas. And it gave him enough protection to get his hand in the lead and out.
Wow.
Now, I wouldn't do it. And I had done this many times before. I just acted like I'd never done it before. But I wouldn't lay it on my tongue. I'd bite it with my teeth. And then you can feel it. You can feel the layer of gas when you do it.
Really?
I don't recommend young people doing it by any means. It's kind of fun to see anyway. Okay, so we get rid of this mess. You want to get this, is there still some in there?
Yeah.
Oh, here, let's pour it out on the tabletop. Let's get a picture of that. And I'm gonna scoot back so that you don't, just pour, I want you to see the Crookes layer. You focus, Cody, just focus right down here. And just pour a little bit and just see what happens. And I'll get back and kind of watch the liquid nitrogen boil. Ooh, there you go. Well, that wasn't supposed, pour it a little slower maybe. It's dancing on a layer of gas. Those little droplets are just skedaddling out of there, aren't they?
Yep.
Yeah. What do you want me to do?
Pour the whole thing out?
Hot water and
Oh, do we want to make a cloud?
is that vapor or cloud vapor?
Well, we could. Oh, you wanted to pour some water in there? Yeah. You want to make a cloud? Is that what you're saying?
Yeah, make a little cloud.
Is there any left in the container?
Yeah. There's like a quarter of a container.
Okay, scoot it out there at the center and just pour some of that water
That's like
in
a
the
half
top.
container. Never mind.
We're going to make a super cloud real fast. You ready?
You want hot water?
Yeah, we're going to get some hot water. Just a second. Just forget that water.
Okay.
Just give me a little pint of hot water. We're just going to make a super cloud.
Super cloud?
Well, a little miniature one.
Super cloud.
Maybe at the end of the thing, we've got enough liquid nitrogen, we can make a big one.
Does he have his own show?
No, you leave that
Super
sitting there.
cloud. Oh, we pour this on there.
Okay. And just, you got your goggles on?
Yes.
Okay. Just pour some of it in there, not all, but just some of it. Just go blub, blub, blub. Oh, there you go. Hey, that's looking pretty good. Pour some more in there. Yeah, pour some more in there. Let's get another. Hey, there we go. Okay. We'll do that on a larger scale here shortly. One more time. See if we got any more left in there. Any more liquid nitrogen? Hey, we got a cloud. We just made a cloud, Kenny.
Looks cool to me.
That's what happens in our atmosphere. The same thing. It just yeah. Warm, moist, and a cold. Yeah. Well, you did pretty good. You made a mess. Thank you very much for that idea.
Bad.
I know. We got to clean all this up here.
Should I move the?
That wasn't on the agenda. We were just messing around. You know.
We do a little bit of that.
Yeah. No, we just messed around. Here, we're going to clean this up a little bit. You guys want to take that out of here? And you carry that away. Yeah, that was cool.
Good stuff. I like the demonstration with liquid nitrogen where the guy takes the latex glove and fills it with water.
Oh,
and
yeah.
dips it into the liquid nitrogen, leaves it there, and then flicks off the fingers. I think that's such a cool experiment.
Oh, you stick things, stick different things in liquid nitrogen and see what it does.
Yeah, exactly. I think it's just a
Yeah.
lot of fun.
You know, I got in big trouble for that once.
Why?
Well, I did it I forgot what the meeting was, but we put, I had a big dewar full of liquid nitrogen, and I put an apple in it, and brought it out and hit it with a hammer and it'd shatter, right? And I put a banana in there and froze it. So then I put on a rubber glove, right? I said, I'm going to stick my hand in there or stick a finger in there or whatever. But of course, I didn't stick my finger in there. I bent this finger down, and you put a hot dog in that part of the glove, right?
Yeah.
And you stick it down in there. It looks like your finger is going in the liquid nitrogen, and it freezes the hot dog. And then you bring it out and tap it, and smashed it with a hammer. I put it on an anvil, and I held it up. My finger looked like it had been flattened out, and I guess somebody fainted and banged their head, and I got in trouble.
Oh man.
Scared them
Where
so
was
bad.
this?
Huh?
Yeah.
Where was
Yeah,
this, Jake?
I know, it's what it is. Here, we got to wipe this water off here.
Hey Jake, why did it generate sound like that? What caused it to be so loud?
Which thing?
The liquid nitrogen, when we poured it out, it like made the gushing sound, kind of like thunder.
Well,
Somebody asked in the comments.
Oh, I see what you're saying. Why did it sounded like thunder? Well, that was Kenny Luna. Kenny sounds like, that's what Luna sounds like. Well, it sounds like thunder. I suppose over the microphone, the escaping air would hit it kind of like a wind. Yeah, it would sound like thunder. You'd sound like wind clapping. I think it was just because there was so much gas escaping all at one time. It'd run into itself. We've got a nice family of viewers. I like these folks. You're all right. I appreciate you hanging with us. We've been talking for an hour and a half.
Yeah.
Oh my gosh.
We're good at talking.
This is amazing. Does anybody need a potty break? Not that I do. I've already had 2 just sitting here, so it doesn't bother me.
Oh.
I know that. At my age, what are you going to do, Get this cleaned off. Okay, let's see what we got left on the agenda. We got more things to talk about. Oh, to my family of streamers, and thank you for streaming with us. We're going to grow this thing. We're going to keep after this for a couple of years. We're not going to give up. We have to grow an audience, and it takes time. When we first did this Midnight Science Club thing, it took us a couple of years, but we got up to where we're having, we've got a million some followers and stuff, but it took a while just to do it. So I know it'll take a while to do. We're so glad to have you, aren't we?
Yes.
Okay.
Yeah, definitely.
Appreciate the comments.
Well, I appreciate the comments. See, Kenny doesn't know. Kenny, this is what happens when you have something. People will send in comments, right?
Right. Yeah, I can't see the comments.
You can't see the comments. Well, see, you never got any because if you'd be a little more friendly, you'd get some comments. But Okay. So there's a book I recommend. Every one of these streams, I'm going to recommend a book because I like to read a lot. And this book is called The Dancing Woolly Masters. Does it make sense? It's not a religious book or anything. it was written by a guy named Gary Zukav back in the 70s. And I think he was kind of a bohemian. He was a character. He would write books on all sorts of things. And a very intelligent guy and an excellent writer. And he, in this book, he said, this is the way, essentially the way to teach science. The Wu Li masters were an ancient tradition of thinkers, and I don't know who they were, the Wu Li masters. It must have been like Mr. Miyagi and the Karate Kid or somebody. Anyway, they say the best way to teach somebody something, especially science, is to not use mathematics the first time through. When you try to explain something complicated, leave the math out. Leave the math out for the first time. Don't clutter it with math. Come back later with the mathematics, right? So he said, for an example, if I was teaching kids, young people, about the acceleration of gravity, I would go, well, you know, things fall to the earth at 9.8 meters per second squared. And a young person will go, a what? I know 9.8 meters per second. What do you mean per second squared? What does that mean? Per seconds. What does that mean? That's very confusing if you don't know what acceleration is and how to deal with it. So he said the Wu Li masters would write it like the petal falls towards the earth faster and faster with greater anticipation of meeting Mother Earth or something like that. And he would make a story about what's going on so you could get the idea. Well, Faraday thought the same thing. He called what he did, not science, it was called natural philosophy. That means science without any math. It's all qualitative, not quantitative. And many of the old thinkers, back before Lavoisier and the real chemists came along, they were natural philosophers. They saw nature and what was going on in it, and they came up with laws of nature, but they had no math involved. They did no measurements. So it was all qualitative. And that's why they came up with things like earth, air, fire, and water are the four basic elements. They didn't measure anything till later on. In about the middle 1600s or so, 1700s, people started to quantify things. But the first time you learn something, do it without the math. And then come back later and add the math, and the math won't be so scary and won't run you off. So he explains in this book quantum physics with no math. And you go, wow, I understand it. Now I can go back and do the math, and it's so easy. If you leave the math out, just the first time through or the second time through, read it, do the science without the math. And that's what I want to do so desperately with Midnight Science Club, is I want to model being a good scientist, but I want to leave the math out for a while, so that young people can get excited about seeing nature without having to measure it all the time. And then come back a little later and those measurements will make sense. So I recommend, if you're interested in quantum physics, but you don't understand it, you say, I don't know what. You get a book on quantum physics and they start talking about this equation and that stuff, and they say, I don't understand, I don't know what they're talking about. So that's why I recommend this Zukav book. It's great. And it's a classic. It says right here, author of the #1 New York Times bestseller, Gary
It looks
Zukav.
fantastic, Jake.
Winner of the American Book Award in 70s. What were you doing in 76?
Me?
Yeah.
I was toddling around. I was 1
Toddling
years old.
around when this great thought was going on, you know?
Yeah,
Jake,
exactly.
Yeah.
Isn't it
The
amazing?
comments want to know
Guys-
if you have any other book recommendations for kids.
Oh, I got tons of them. Well, for kids. See, what would be good for kids?
Well, something like that didn't use a whole lot of math. So I could
Didn't use a
understand it.
whole lot. Didn't use a whole lot of that. I could just happen to have. And if you contact us, since you asked the question, bring me a stack of books, Cortland. Yeah, the hardware science books. Yeah. She asked a question. I'm not that much of an author. I write.
For a little bit older kid, I enjoyed Stephen Hawking's. I think it was a brief History of Everything or Brief Theory
Oh,
of
yeah?
Everything. Yeah, it was a pretty good book. I forgot. I'm trying to think of the exact title, but it was pretty interesting.
Stephen Hawking book?
That would be more for like a middle school student.
Be good for a middle school, yeah. So we'll figure out a way to get some of these to our viewers. Maybe we'll send that guy, whoever it is, you contact us, we'll send you a set of books. But I put together a set of activities, and I've got 2 more to write. There's red, orange, yellow, blue. I've got the blue book and the green book. I did the prism book. I'm going to do 7 of these in the series. But it's science activities you can do with stuff you find at the hardware store. The Wizard's Books of Science Secrets. And it's just a recipe book of things you can do at home, growing a crystal or blowing up something safely. Making a what? A bug habitat. Look at that. How to make a bug habitat.
Dang.
I know, that's what I'm saying. How to scare your neighbors at Halloween. That's a good one.
Yeah.
That's a really good one. How to terrify your neighbors at Halloween. Oh, well. Anyway, we'll make these things available somehow. I don't know how we'll do it, but that, I mean, I don't know, just general reading. I would say if I will trump you a little bit about the reading. I would encourage young people not to worry about science before the 4th grade. I would focus on learning to play a musical instrument and reading. Yes, reading anything, just a practice of reading, but by all means. I don't know if I told you that story. Did I ever tell you this story?
I don't think so.
So, we don't have a picture of our Nobel friends, do we, Jacob? Do I have that picture?
I'll tell you, Jake, getting kids to read anything is so impossible.
It is?
It is impossible. It's so difficult because they've got it's a visual world. It's not like it was 30 years ago or
Oh,
more.
yeah. Tell me about it.
Where the written word was the king.
Yep.
It's all video and it's a different world, so it's very difficult. I know I've got a 14-year-old, and getting him to read anything is virtually impossible. He'll read for school because he has to, but reading anything for pleasure or to learn something is very, very difficult. Now,
It's actually painful, isn't it? It's painful to
It
sit
is
still that
painful.
long. And,
it is painful. Now, what's interesting is my older guy, my
Yeah.
18-year-old, he's in college, and he's discovered he's dyslexic, so he struggles with reading, but he's discovered audiobooks, and he's been devouring them, and I've been so grateful that he's picked up on that. You know, like that he can get in. You know, reading is where all the smart people are. You know, it's
Yeah.
where they're communicating with each other. And how do you encourage kids to read? I try to encourage kids in my classes to read all the time. But I got some kids that come in and, you know, you just tell that they're readers. And the readers tend to be, you know, I hate to say head and shoulders above the rest, but they really do stand out. And that's because of the fact that they're reading. They're communicating with some of the best people out there without even talking to them. They just experiencing them, experiencing their ideas, you know, and it's you know, anything you can do to encourage your kids to read. And I say that from a place of anybody who's got ideas that I can use to encourage my own son to read, I would be grateful for.
anything that'll get them to put the phone down and do something. Well, anyway, I tell this story till people get sick of hearing it, but Wizard 2's neighbor, a door over, was Albert Einstein in Princeton. And on Monday nights, they would get together, these guys that came over from Germany and Europe to get out of World War II. They wanted to get to the safety of America, and most of them went to work at the Institute for Advanced Study and places around Princeton. And Dr. Allier taught at Princeton, so he was Einstein's neighbor, and they would frequent each other's company once in a while. And on Monday nights, a group of those scientists that came over would have dinner just to eat the food, because Americans didn't know how to cook anything right. You know, they were over here in this strange country, and they would get together and have dinner in each person's house. And they would always get together at 6 o'clock and eat dinner for an hour, and then for 2 hours they would discuss a topic of interest. And you know, one Monday night they might talk about dinosaurs, and one night they talked about how to make an artificial brain or a computer. They were talking about that, and one of the attendees, most of them had a Nobel, was John von Neumann, and he left that meeting saying, I'm going to go work on that, a circuit that would do that. And that, that was the beginning of the computer, that mnemonic circuit that he developed. So there were a bunch of smart guys sitting around, and Doc Allier had to bring his daughter along to babysit one time, and didn't know what to do with her, so she sat underneath the table and played with her toys. And one of the professors said, is she going to be as smart as you are, Professor? And he went, I think so. So they started thinking about what they did as children that made them so smart, because they were all brilliant scientists. What did we do when we were 5 years old, 10 years old, 11 years old? They made us so smart. Mm-hmm. And normally those people would argue about things. They'd debate and get red in the face, screaming at each other and having a good time. But that night they all agreed. They all did the same thing when they were kids, about 9, 10, 11 years old. You know what it was?
Reading books?
Close. They did read, because they didn't have cell phones. Can you imagine that? The agony of not having a phone. Oh my God. You're close. They all played a musical instrument. And Einstein would play every week with one of his buddies, and he said it taught him how to dream and how to picture things in his head and how to think and dream especially. And he said that they all nodded their heads. They said, yeah, studying music. And Einstein would pull out his violin and everybody say, please don't play. But he's a good man. But anyway, he and Max Planck would play together and discuss the world, but they said it was the music that. If I was, king of the world, I'd say, look, every kid's got to learn to play a musical instrument, a piano and something else, and it will do more for their brain than anything. Do you sing?
No.
Okay, please. Okay, I don't either. I do play the piano, however.
I sing in the car, Jake.
Do you sing in the car?
Yes.
It's a good way to clean your windshields, I bet.
It probably is.
I want to do another science. See, what else we got? Oh, we got so many more things. I just told you the thing, the wizard quote, okay? I'm going to have people, Kenny, I want you to look at the shelf when we're in the background. Sometimes you see something, you say, what is that? Because, we have the world's largest collection of science stuff here, right?
All right.
Okay, so I'm going to do that while we're setting up. So I think it's time to do our big test for the evening. I want to find out if that fire is going to travel through that tube. You want to help me set it up, Cortland?
Where's the ring stand?
Oh, yeah, where is that ring? Ta-da. We're going to set this up. I'm putting a ring on my ring stand, my Allier stand. There it is. Okay. Oh, my gosh. And I get that in because I'm the wizard, right?
Yes.
Okay. Now I have this end here, and I have a tank of gas. You ready for this, buddy?
Yeah.
Okay. I would let you do this, but there might be an accident, and you might want to have children someday.
I like my fingers.
I know, that's what I'm saying. So I've got a tank of, this is MAP gas, and what is MAP? Do you remember, Kenny, what MAP gas is?
The map guesses. I know.
No, it's got acetylene in it or something in it. I don't know what it means.
Yeah.
It's a mixture of gases, methane, something or another. Burns a little hotter. Yeah. Kind of tastes like banana pudding. That's why they put it in a yellow tank.
Uh-huh.
Are you buying that?
No.
No, okay, never mind.
Have you tasted this, Jake? Have you tasted?
No, I haven't, not on
map
purpose.
guess?
But I tell you what, I'm gonna stick this torch into this tube, like that. Pull the trigger, and gas, flammable explosive gas, is going to come through here, and it's going to travel through this tube. Going to go up and around and down and around and down and around and down 3 or 4 times, and then it's going to land up right here at this Pepsi bottle that I've got here, this 2-liter bottle. All right. Now, in order for a fire to burn, you need 3 things, right? What are they?
fuel,
We need oxygen.
oxygen.
and
It'll come to you. Fuel, oxygen, and
spark.
so yeah, heat. You need some heat, right? Yeah, see.
Yeah.
The Dancing Wooly Masters, yeah. So there it is. So right now I've got the fuel, right?
Yeah.
And you see these little vents right here on the pipe there? There's little vents. This torch head will draw in air, right, to mix, and it mixes the air with the thing. So we've got both things going through the tube. We got the fuel and the oxygen, right?
Yeah.
The third thing is heat.
Yeah.
Say, who's going to apply the heat? Well, this little torch right here has a piezo igniter. So when I pull the trigger, there's a spark up there, right, that ignites it. So, but I can pull this halfway, and it won't leak out. I mean, it won't spark, but the gas is coming out. So if I pull it halfway, gas comes out, mixes with air. If I pull it all the way, it lights up. So in a minute here, I'm going to stick this in here, run it for about, what do you think, Gordon, about 20 seconds? Yeah. About 20 seconds, I'm going to fill this pipe with gas, and the flame is going to go skittling along, just having a good time. Now, we've done this, I don't know, 20 times online, but the question, this is advanced thinking. This is going to get you up your scale and your wit level.
Oh, boy.
I'm telling you. That fire is going to go up in that tube, and it's going to come back down. Do you think it's going to go faster uphill or downhill, or stay the same?
I think it's going to go faster downhill.
Yeah, Jake, you asked me this earlier, and I really can't. I mean, it seems logical that it would be faster coming downhill, but I don't know that. I don't know.
The heat goes up some, doesn't it? Hot stuff go up.
Right, hot stuff goes up. Yeah.
Now, see what Kenny's doing right now is absolutely pure science. Well, natural philosophy. He's not putting any measurements to it, so he's actually philosophizing. He's doing natural. He's trying to solve it in his head, and that's the whole purpose of everything we do here, is to get young people to enjoy thinking the way he's thinking right now.
Yeah.
Because Kenny doesn't think more than an hour on Monday, Wednesday, and Fridays, and we caught him on Monday, so it's good. But just to get a young person to pause for 10 seconds to solve in their mind, I think it's going to do this, I think it's going to do that, and then they have to watch carefully and make an observation. Did it go faster or slower? And that right there, that's all I'm trying to get young people to do. I'm not trying to get them to measure the rate it's traveling or what's the chemical reaction or balance it. I just want them to enjoy the exercise of thinking this way. So here we go. I'm going to pull the trigger, and we'll do this more than once in case it doesn't work. And would you point towards the fire extinguisher, please? Where is it?
It's over there somewhere.
Well, let's see if you see it.
Right there.
Right there. It's red. Right, you can't miss it. Yeah, you don't want the smell of the burning away. There, yeah, okay. Yeah, okay, here we go. I'm going to pull the trigger. Okay, so now I'm filling it with gas. 20 seconds, is that about 5 seconds? Yeah, okay. Is that about 10 seconds? I don't know. What are you thinking out there? Maybe about 15 seconds? I don't think this has ever blown up, has it?
I sure hope not.
Okay. Here we go, 20 seconds. I'm going to do a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Here we go. Up, down, up, down, up, down, up, down.
Boom.
Okay. Boom.
Wow.
Could you tell a difference? Could you see it, Kenny?
I could definitely see it. At the turns, it obviously sped up, or at least appeared to. I'm not sure which was faster, for going up or going down.
By the way, I'm filling it up again. We'll try it 3 times just to see.
I'm with Kenny. I think the corners were fast, but I think the up and down was about the same speed, at least it looked like.
It looked, yeah, I would, Beck, I would agree with you. I think it looked pretty similar.
Isn't that amazing? That we go, if it is the same speed, that, of course, see, that's a natural philosopher would, and then a scientist would say, well, hold on, let's measure it, right? And that's the tough part of science sometimes. Say, oh, you want me to be accurate? Oh, okay. I just rather blow it up. Do I have to be accurate? I guess, I don't know. But today we're natural philosophers.
Today
We're just doing
natural
qualitative.
philosophers.
Do you think
Yeah.
it goes faster on the turn?
Yeah, I do think it looks faster on the turn. But that could just be because it's close
That
together.
could be an illusion.
Yeah.
Well, let's check it. Let's watch the turns now and see if it does. Because you know there might be some centrifugal force, some whiplash going on.
Right.
You know, cracking the whip. Here we go. 3, 2, 1. There it goes.
I rescind my statement.
What do you think?
I think the whole thing's the same.
The whole thing everywhere?
Yeah. Turns, straights, up and down.
Really?
What
is that?
I think it's the same because you're feeding it gas.
Okay, this time I will turn the gas off. Because the other times I was feeding it gas the whole time. Pressurize it.
Right.
So this time I'll pull the trigger and I will, once it gets going, I'll let the finger off, see what happens.
Yeah, that makes sense.
Let's see if that happens. See, the people watching, they're going, this is cool. There's grown people doing this. This is only in America. Here we go.
America's right.
Good angle.
Good angle. You ready, Cody? Man, the cameraman is. Here we go, Cody. I'm going to count it. 5, 4, 3, 2, 1. Fire. Ooh, I took the flame off. The pressure. Oh, look at that. Oh.
Yeah, definitely. It gets stuck at some spots and then speeds up. I still think at the turns it gets faster.
Oh, didn't even make it to the end. Ran out of something.
It was hard to tell from that angle. I think we're gonna do it one more time.
One more time.
Again. Yeah.
One more time. Do you want this one with pressure or without?
No pressure.
Well, we did
No
two
back
with
pressure. Okay. I gotta fill the tube one more time. Let's see what Socrates. Read that. What it said. Socrates said
something similar about children being taught music early in Plato's Republic.
Yeah. See, Socrates. Is that how you say it?
Yeah.
I thought it was Socrates. Is that how you say it? Socrates. He had a friend named Plato, right?
Yeah.
Yep.
Plato and Socrates.
And Aristotle.
Yeah, Aristotle. Yeah, Aristotle. Yeah, I know all the famous guys. You know, Bach and Mozart,
Seneca.
Beethoven. You know, I know them all. Here we go. 3, 2, 1. No pressure. That is kind of cool.
Yeah, it's like inconsistent.
Yeah, that's. I agree. I agree.
Well, it didn't make it to the end. Doggone it. Anyway,
The comments wants us to do it again with pressure.
one more time. Comment. Do it one more time with pressure. We want. There we go. Fire it up. I'm getting kind of lightheaded.
Yeah, I'm getting
a little
gas
buzz
coming
here.
over.
I'm not into drugs or things, but I'm getting a little.
Well, but we do like vaping, right?
Well, vaporing, not
Vapors.
vaping, but vaporing. Yeah, we're vaporists. What I'm thinking. Yeah. Oh, well. All right, here we go. And 5, with pressure, back pressure. 5, 4, 3, 2, 1, go. Here it comes, here it comes, here it comes. Woo!
It definitely goes faster with the back pressure.
Yeah.
And it looks more even with the back pressure, too.
Yeah, it does. Well, it doesn't make much to make us happy.
Fire good.
Nope.
Fire good.
We like fire.
Oh, have to take just a little break here to get some. Boy, that stuff stinks, doesn't it?
How do you think the bottle on the end affects the loudness of the pop?
Well, I think it's what causes the loudness. It's kind of like a tuba.
So a bigger bottle would mean a louder pop?
Man, he's starting to think like, okay,
Well, the comments are thinking like a scientist.
yeah.
Yeah, no, not me.
All right.
It's on muscle. Muscle car.
Well, let's see.
Good job, Pat.
What can we put on the end? Hey, we're going to work on that. Now, see, my muscle friend, see, now I get to do this all again with a bigger thing. We'll get a whole set of things on the end. See, I get to do this again.
Thank you for the opportunity, Muscle Car
Yeah,
Pat.
muscle guy, whatever. He's a good guy. Drink water. Hey, I have to do it because our guys want us to do it.
Yeah.
Here's a fun thing. You guys will get a kick out of this.
Okay.
We'll do a small, but you get rid of that thing there.
Sure.
Thank you. This is the silliest thing. I will tell you a story. So Jacob Brown over here in Saudi Arabia, they have an annual science festival, and they hadn't done it for a while. I guess there was some war going on or something over in Saudi Arabia, and they invited us over to have a booth at the science festival. We don't have any pictures of that, do we? Yeah, there we go. Saudi Arabia. And that was my little interpreter there, gal. Just see sweet people. Look how they dress. Isn't that amazing?
Yep.
Yeah. And a lot of the girls, they didn't even show their whole face. They had to just look out through slits.
Oh, yeah.
They kept covered. It was Girls' Day, there at the thing. I got in trouble.
Uh-oh.
Yeah, what'd you do, Jake?
Well, I was over there in the booth, and I had these 2 young ladies who were translators. And they were just as sweet as they could be, the nicest people. And you hear stories about the Middle East and the fighting and the terrorists and this stuff. And I got over there, I was a little nervous, and those people were so sweet and kind and polite. And you'd say, well, this isn't what I expected. It's the sweetest people. But there are a group called the Religion Police that is a tribe of the ancients there who monitor and I'm not against their religious beliefs at all. Everything's fine. But I broke one of the rules. And it caused quite a thing. Because they said, here comes the visiting professor from the United States. And that was me. And when the girls were done, I put my hand out to shake their hand and say thank you so very, very much. And you're not supposed to do that. You have to wait until the young lady puts her hand out first. That was just a small social faux pas. Mm-hmm. But what made it even worse, what I did, when she put her hand out, I grabbed with my right hand, and I took my left hand and grabbed her other hand, and I shook it, and I said, I want to thank you for what you did for me. Putting that second hand on there. Woo, here he came.
Double technical.
Oh, double technical, and he chewed me out. Luckily, he was chewing me out in Arabic. I couldn't understand a word, so I just sat there and nodded my head like an idiot, and that made him even madder at me. But I broke another law later on, and here come the religious guy, and he said, with his eyes, he said, I've got this guy nailed. Good old Jake, he's done it. He's gone way too far now. And the rule that they were breaking is the girls they were laughing too much. And they were acting.
Can't have too much fun.
They were having too much fun, and they were acting unladylike in public, and they were giggling
Really,
and laughing
Jake?
and carrying on.
This was really
I
a
caused
thing?
that. Huh?
This was really a thing?
It's really a thing. And my interpreter, Kareem, was standing there. He said, Jake, keep your mouth shut. Don't say anything. You're going to get a little trouble here. And all of a sudden the TV cameras came on and outside the booth. And it was the prince, the big prince. And he walked to the door and looked who it was and what was going on. And he smiled at me. And he raised his hand and said, he is forgiven. And
Lucky you.
oh yeah, lucky. And the policeman was really mad, like, oh no, I was going to nail him. And so later, I think he felt kind of bad that he thought I was mistreated or something. Of course, I wasn't at all. They gave me a real nice plaque, and they gave me a tea set and stuff to kind of thank me for coming. That's what's over there in the case. I'll get it out someday, show it to you. So anyway, this is what we did at the festival. And they had everybody who went to the festival to write an evaluation, like which was your favorite booth. And there were, I don't know, how many booths were there, Jacob? 50? I don't know.
You said
Talking
hundreds.
to kids too, or
No, just the number. Well, yeah, the kids, there were probably another,
exhibitors? There's probably 100 booths.
yeah, 100 booths, 100 people. And there was like Ford Motor Company and this and that and aerospace something industries and big companies. And then here were these schmucks from the Faraday
Wichita.
studio, from the United States.
Can I say that?
And, we were voted number one.
Were you really?
And they had people lining up.
That's hysterical.
Please take my child into your booth.
That's
And
funny.
this is the activity we were doing. Are you ready for this?
Yeah, I'm ready.
Wait, a little more. We gave the kids a bottle like this and a little bottle of alcohol, which was not easy to get in
I was
Saudi
gonna say, I
Arabia.
feel
I'm
like
going to
that
say
was like one of their
alcohol.
rules, too.
You know, they thought ethanol, but we got some. And the idea is that you put a couple of drops. We don't tell them how many drops of alcohol to put in the bottle. And
We didn't have methanol the first day. What do we have, Jake?
oh, we had perfume. The first day we didn't have.
My hands smelled awful for weeks.
You smelled like an old dancer, didn't you? We couldn't find any alcohol in Saudi Arabia because they don't consume alcohol at all. But we found some aftershave or some men's perfume or ladies, whatever it was.
Both.
All of the above.
So we used that for rocket fuel. And we made these rockets. And here's the rocket, you ready? That's it. It's a cork with a balloon on the top of it. There's a cork. And we would stick it in here in the bottle, like that. And they would put a few drops of alcohol in here. And then we would use a charging coil that I just happen to have one here. Right here, I can turn it on. See, is it on? No, it's not on. Hold on.
Lick it and find out.
Huh? Oh, this switch here. Yeah. Yeah.
No,
No. See that?
I think it's on.
It's on. Did the TV go off?
We killed it.
Oh, no. Okay. This is the way I floss my teeth at night.
Really just blew out my teeth.
Did it just make the TV go off?
It blinked. It blinked.
We're back. We're on stream.
Well, that's kind of cool. Don't mess with me. I'll erase all of you.
Like Men in Black. I'll bleep you. Do it again. Do it again.
No, I better not because we might lose the signal. I just fired this thing up. It's called a. Let's see the name of it right here. Can you see that name? What is that?
Audi coil.
Auden or Whedon? I don't know.
Uden?
But it's what they use to find vacuum leaks. I can take this thing and run it along something we think has got a vacuum leak, and that spark will go right down the hole where the air is running. So it's called you can use it for a leak detector, like on a tractor or an engine or something. You know, you'll see this spark. But this is just a transformer, and it gets up to about 6,000 volts, I think. 118 volts going in, 6,000 going out, something like that.
Jake, I'll be right
Makes
back.
a nice little spark, huh?
I'll be right back, brother.
Okay. He's got to go. He'll be back. Kenny's leaving, but we'll try to do without you for a few seconds. Okay. Yeah, I know. Hey, when you get old, you got to go. When you got to go, you got to go.
Nothing you can do about it.
You know, you got to go, you got to go.
Did you say you went twice already?
Yeah, right down here in the carpet. Cortland, we got something to clean up here later. So what we did, the kids would have one of these, and they could touch it to this wire right here, and it goes inside, and it makes a spark jump inside. It acts like a spark plug to set off the fumes that are in here, because we're talking about fumes and vapors, right?
Yep.
Okay. So, and what the challenge was, I said, this cork is going to pop out of here, depending if you get the mixture right. If the vapor you make is carbureted grossly. And they said, well, how are we going to do it? I said, I don't know how many drops of alcohol you should put in there. You've got to figure out a way to figure that out. And the idea is, we were in a great big arena. I said, if you can make this go as high as it can without hitting the ceiling. If you hit the ceiling, you're disqualified. You want to get as close to the ceiling as you can without hitting it. So the kids were testing with 1 drop of alcohol, and then 2 and 3, and they were actually doing a little scientific method. They were actually doing a little bit of science, tracking it, writing notes, which was just great. So we're going to do it right now just to show you what I'm talking about. I got some alcohol. You want to do it? Sure. That's a drop. Here, you can put it in there. You count how many drops you put in there. No, you got to have the alcohol, don't you?
I was going to say.
Duh. Here we go. There's 1, 2, 3, 4.
Should we call it or do more?
5. Keep going. 6. You guys kept it 7, 8. Those are pretty small drops. 9. Let's do 15. 10, 11, 12, 13, 14, 15. Okay, there you go. Whatever it was. That was 15. He just spit on me.
Sorry.
What? It happens. Look.
Yeah.
Now, who would have thought that would have happened?
Not me.
What if that had been nitric acid?
Well, the paper would
Look
be
at
good.
it. It got spit out on my paper. How'd you do that?
I don't know. I didn't squeeze it. I set it down.
Well, isn't that amazing?
Yeah.
That was kind of like an accidental misfire. That's a lab accident.
Uh-oh.
Good thing that wasn't acid, right?
Yeah.
Oh, my. So you put 15 in there, right?
Yep.
So why don't you mix it with the air? Now, how are you going to do that?
Like that.
Do that. Put your thumb over the hole and just shake it. Shake it really good. Give it a good shaking. Yeah. Here we go. There we go. See, I win. I told everybody I couldn't make him look silly on their TV. There you go. I got it.
Got me.
I got the cookies, man. This is great. Okay, so there it is. Now I'm going to have you do this.
Okay.
You'll turn this thing on. Right there's a little button right there
Yeah.
you push. Right there. And you're going to bring it over and just touch it with one of those wires. And hopefully there'll be enough to make that cork fly out of there. And if not, then here we go. Give us a countdown.
3, 2, 1.
Okay. No good. Not enough. Okay. We learned. Okay. Turn that off there. I don't even think we got enough in there to do anything.
I guess not.
I'm back, Jake.
Huh? You're back? Were you gone?
back.
I never noticed. Yeah. I think those drops are so small there, we didn't get much.
Okay.
So we'll try it again. I'll put that really puts out a really tiny drop. We'll just
Yeah.
put that much in there.
There we go.
When we did it in Saudi Arabia, they counted it out. And those kids got so excited because the cork will pop out and they'll go, oh, almost, and a little more. Put in 2 more drops. And then one thing we had them do is, I wonder if you warmed the bottle, if that would make any difference. Add some body heat to it, you know. I wonder if warming the bottle would make any, you think it would?
Maybe.
And they were trying to think how to do it. Hopefully this will work.
Yeah, well, the warming the bottle is going to add more vapor to it. I mean,
Yeah, but you can put in too much and you what do you call that? It needs to be choked. So go ahead and give it a shot and see what happens.
All right.
Yep, 3, 2,
3,
1.
2, 1.
Okay. We're not having any luck at all today. Are we getting a spark?
I don't know.
Huh? We might have to bring this back next week. If this is not going to work, we'll just be awful upset. We'll have to move on to bigger things.
More alcohol.
Well, we'll just do a bigger version. There we go. Put a little more alcohol in. That's pretty, ought to be enough alcohol. They would actually, when they were doing it, they would measure how much alcohol and which way it would work. Are we doing anything wrong, Jacob?
Oh, it seems like it's fine.
Huh?
Seems like it's fine. I don't know why it's not going off.
Worked earlier today. It didn't stop working until you showed up.
Maybe it's me.
I'm just wondering.
It's all the wit's fault.
Yep.
All right, here we go. Let's have it. 3, 2, 1. Okay.
I just think you need to change bottles.
Huh?
I think you need to change bottles.
What do you have, another bottle, Corlin?
No, that bottle's too small.
Oh, you want to do it with the big bottle?
Well, that one doesn't have enough air in it.
Well,
Am I full of it?
do I have another one of these?
Upstairs.
No, never mind. Don't worry about it. Don't worry about it. We got another bottle then? Well, you want to do a bigger bottle?
I was stupid. We should do a bigger bottle.
Well, let's do a bigger bottle then.
Bigger
Heck
bottle.
Heck with it there. Get that out of there.
Get that out.
Do we have one like that?
Huh?
What type of bottle you want to use, Jay?
Well, I'm tired of messing around here. I just can't do it. I just got to do it right here. We'll just do it. Let's do a bigger bottle. If that didn't work, by golly, we'll make this one work. What do you think?
Looks good to me.
That certainly is a bigger bottle. That's a fact.
Have you ever done this before,
No.
Kenny?
No,
Called
I
a
have
whoosh.
not.
You've not done it? It's called a whoosh bottle.
I've seen it done. I have done it myself.
We must not be getting the spark down in there. What do you think? Not getting a spark. We're going to work on it.
I don't think so.
Don't be upset with us, folks. We'll get this working. Maybe not this week. We'll have it next week. I'm embarrassed.
Try one more time.
One more time.
Well, the sparkler's right there. Just push the button, right?
Okay. Go for it. Okay. No. It worked. It worked today. If I'm lying, I'm dying. I tell you, it worked today. I don't know. This is methanol, right?
I think it's water.
Did you put water in here?
Doesn't smell very good.
Taste that.
I'm good.
It's alcohol based for sure.
You know, you're not supposed to smell a chemical like this. You're supposed to go like that. I just did a bad thing in front of all the people.
Uh-oh.
This might be bad alcohol. I don't know. I'm going to put some alcohol in there. There we go.
Are we just zapping the bottle this time?
Now we'll drop a match in.
Does it matter how much you put in, Jake?
Not really, because it will saturate. Now I put about 2 tablespoons in there. Normally I'd use like a 5-gallon milk water jug. We just happen to have this
Yeah,
one.
I've seen it done with that. Yeah.
Okay. So I'm gonna have to do it myself because of insurance.
Okay.
Because you know your grandparents get all upset. You remember the times at the hospital they said, "Do not do this to this poor
Don't.
kid again." I don't. Okay. What did you do?
Change alcohols.
Huh?
Change alcohols.
Did you? You put a different.
Propane in it.
You put isopropyl?
Yeah.
All right, hold on. Here we go. You gonna fire it?
3, 2, 1.
Okay.
Yep.
Yeah, it fired.
Talking about bottle, we're fine.
Boom. Well, heck. We had some bad alcohol, Kenny. Did you see that thing take off?
No, I didn't actually.
I could hear it pretty well.
You did.
Yeah,
Did you see the little jug go off?
no, I didn't.
Did we not get that on camera?
No, you did. I just looked down for a second.
Oh. You fell asleep right at the key moment of the whole evening?
Come on.
That
Oh,
sucker
Jake.
flew, didn't it? So was isopropyl. So that must not have been good alcohol.
There's your fresh methanol, or you can switch over to isopropyl.
Yeah, give me some isopropyl. I don't know what to do now. I'm embarrassed. I don't even smell any fumes.
I could smell it when I got it on my hand. But that's really about it.
Well, I'll put a little isopropyl in there too then. I think I had some old alcohol that must have gotten contaminated or there's some water in it or something. Anyway, we'll put a little, there we go. There we go. We'll try that. Now, I've done this for 55 years. Done this demonstration called the wish bottle. And I've only had it blow up twice. So
What did you say?
I
blow
found
up?
out
What
that
do
you can only do this about 15 times in the bottle, and the bottle gets brittle and will split, you know. And so I have a lot of life insurance, so my wife says, do this all I want. It's fine. Okay, there we go. Okay, the old man will stand up. Yes, I will. And what's inside here?
Alcohol and air.
In there. Well, what do you call that mixture?
A vapor.
A vapor. Is it a fume?
No, there's no solids.
It's not a fume. There's no solids, suspended solids. Oh, that's nice. I hope this works. Oh, my gosh. Get your cell phone out and dial 9-1, and then hold your finger over the other one. You ever say that to anybody?
Nope.
Okay, here we go. 3, 2, 1.
Uh-oh. Well, there goes our bottle.
Guess there's a reason we don't use those.
Now we
I
know
don't
not
think
to use the cheap bottles.
How much can we
I was
shrink
gonna
it?
say, I don't think that's what we were expecting.
Okay. That
Somehow
was
I'm not
not,
sure that was the experiment.
that was not a good thing.
But that's science, Jake. Sometimes science doesn't work.
Somebody said it must have been the 15th time.
Must have been the 15th time. Well, so we tried. I don't know how we
tried.
messed up tonight, but I think that first alcohol, that methanol, I'm gonna throw that out and get some fresh methanol. I don't understand it. No, I've never had that happen before. Of course, the bottles we usually use are 5 gallon, and they're thicker
Right.
plastic. Yeah, this is
Yeah.
a corrugated thing, and it's real thin and flimsy, but it's like, I'm gonna save that. Put that up on the shelf.
Yep.
Wow, that's all right. Yeah,
Remember that one?
yeah. Do you want to run that? Oh, now see, that's the way it's supposed to work. See,
It's not a video, it's just a still,
just a still.
but we did different elements in it. Center one's potassium,
Oh, yeah.
copper.
Are you throwing that out?
That's out, yeah.
Yeah.
Yeah, so that's a regular jug, the way it was supposed to go, okay?
Right.
And press everybody.
I saw
Instead,
you do it, Jake, where you had it on track
yeah,
at the Young Scientist Challenge years ago, where you had it on a track,
yeah.
and it went whoosh down the track at like a jillion
Yeah, I
miles
did
an
that
hour.
sideways. Were you
Yeah.
involved with that one?
Yeah, I was. That was cool.
In DC?
Yep. Yeah,
Now,
I
you,
was.
you folks might, we got to save this, set that over there somewhere. That's cool. I'm going to remember that.
Toasty.
Matter of fact, if I die, I'm going to put my ashes in that thing.
Oh.
I think that'd be appropriate. You
And
know,
then do a whoosh bottle.
do a whoosh bottle. No, Kenny was, Kenny's a famous guy.
Yeah.
Now, what was
Famous
it? What
guy,
was it? It was what was the organization you wrote for online?
Tree hugger. Tree hugger.
Tree Hugger.
Yep, I did.
And what year was that? You were at the very beginning of things going online.
Yeah, I was back in 07, I would say. 06, 07, 08, in that ballpark.
A quarter of a century ago, you were.
Yeah.
I wasn't even born yet.
He wasn't even born yet, but he was a quasi-famous. He's famous. He's famous. No quasi. He's a famous guy.
I don't know if I'm famous, but I
Oh.
did write for it was a great website, I gotta say. My buddy Graham, who founded it, did a fabulous job. And the people who wrote for it really, my colleagues were fantastic, and it really did well. And that's why Discovery ended up buying it, and that's why I ended up meeting you through the Young Scientist Challenge, which
Yeah,
was a lot of fun.
Discovery
It was
Channel.
really great for
Yeah.
kids.
You know, that was back. I remember when I was at Discovery. I was chief scientist at Discovery for 13 years or so, and they started this new thing. Jake, we're going to have something called a website. A website. And I go, what is that? A website. And there was Kenny Luna, one of the pioneers of this new brave thing called websites.
Yeah. Or blogs.
And look what happened
anyway.
to him. He ended up being a middle school science teacher.
It's true.
It's a tragic story.
Well, I always was. I always was a middle school science teacher. I just ended up there sort of on accident and had a lot of
Why don't you
fun.
unplug that? It's right down there. So you don't accidentally turn it on. Right there.
Yeah.
Pull that out. Well, good. Do you do any more tree hugger stuff?
No, Jake, I don't. I just teach my classes.
Just teach your classes and put in your time. How many more years you got?
5 if I want.
5? 5?
I think I'll stick around longer than that, but I got 5.
Yeah, okay. Okay, we'll do this one last thing, I guess. We'll do one more demonstration and then call it a night because my throat's getting tired.
Yeah, I'm getting tired too,
Huh?
Jake.
Are we doing the trough?
Yeah, we're gonna do the trough.
All right.
We're gonna set up something. This is probably the dumbest thing we're gonna do.
Is this the fart one?
No, the speed of the fart, we'll save that because.
Oh, okay.
Yeah. I want to have a full. So we're setting this up. Would you scoot this down over to there?
Jake, what's
Just the
that red thing behind your shoulder, like above your right hand shoulder? What is that red thing?
That would be a slump.
Right over here.
Yeah, that thing.
That's a slot machine.
Really?
It is,
So you want this
and
one?
it's got a bent dime in it. So I mean, for like 6 years, I've been going to clean it out because everybody comes in and plays it, and I get all their money.
Huh.
Yeah, let's scoot it down there a ways. So Cortland and Cody worked on this. This is a Cortland and Cody demonstration that we're putting up to celebrate vapors. There it is. Oh, look at this. Look at what do we have here?
Oh boy.
Okay, you got that. You gonna put some tape on that or something? Or?
It's magnet.
Oh, got magnets.
Sweet.
Need to light that at some point?
Okay. Oh, now this is getting scary. Oh, wait till you see this, Kenny. This is pretty cool. We put a trough up.
Yeah. Well, I see the
Oh,
trough.
yeah.
I'm a little confused by what it's going to,
A
but
trough.
It's up on the stairs. It's coming down.
It's coming down.
all right.
So what did you got? What do you got in the pictures? Cortland has some pictures. Better take a second one with you. You got more than one filled? Okay. He's going to fill them up. You know what butane is? We'll go and grab one of
All right.
those cans of butane. Hey, I want to thank everybody for signing on and hanging with us.
Yeah, thanks so much.
I'm so pleased to have a small group of people signing on to this thing. We're going to grow it. I know we will. Look at here, Bronson butane fuel.
Do what?
Butane is 4
the bison.
carbon atoms hooked together, and it's very flammable. And according to this, it is twice as dense as air, which means it's heavier than air. So we've got a gas that's flammable, and it's twice as dense as air. So Cortland, do you have life insurance, Cortland? Got paid up? Sure. He is going to pour a pitcher of butane down the rain gutter. Celebrate our thoughts about vapors. Is that vapors do come in different densities. Not all vapors are alike, and that was the point to get across, is that you can have a vapor that goes up, and you can have a vapor that goes down, and you can have a vapor that just hovers in the middle, because vapors have different densities.
Yep.
So this is to demonstrate that. So Cortland's got a pitcher full of butane out of a tank just like this. Fill the pitcher up, and you're going to take a lighter here and light that candle right inside there. I'll hold the fire extinguisher. You see a little candle in there?
Yeah.
Now, I want you to light that candle. You got it lit? Okay. Now, you got the fire extinguisher ready?
Right here.
Okay.
Safety.
Safety. So
Fire.
Cortland Elliott is going to,
Butane. Don't put that on the table.
don't put that on the table.
I got it. Check.
Get rid of this stuff.
All right, messing everything up. We're all safe and everything. I have no idea what's going to happen. I've got my bottle of water sitting here to throw on it. Something.
Is that light okay above it?
Is it lit down in there? Can you see the candle down inside? Show everybody it's lit.
We're good.
Okay. I want people to see that there's a little bitty candle down there in the bottom.
We saw it in there.
Oh, okay. So do we dim the lights or what?
I don't think you need to.
Well, let's find out. We can do this all night long. Here we go. Here comes the butane down the trough. I don't see a thing.
Oh.
Very nice.
Hey, all right, man. Did you see that?
That was cool.
Oh, we got to do that again.
Hit
Hold
me
on a
again.
second. Is it still lit?
No, we're not.
Okay, it went out. You want to light that? Now hold it. Go ahead and light it.
I was hoping there was no more butane in there.
Scared him. Now, did you not? You notice he poured that, right? And you didn't see anything. Is that right, Kenny? When you were watching it, did you see anything?
Yeah, I did. It looked fantastic.
Well, when it finally hit, but before, you wouldn't know there was anything coming, would you?
No, you wouldn't. You wouldn't know. There was
You wouldn't
anything.
know. That is so cool.
Yeah, that is cool.
I think here we're gonna go. We're gonna do this. Oh, here we go. He's got to fill it up again with butane. That's a good shot. Wasn't that a good shot?
That was. I agree.
So what did I learn about butane? It's heavier than air, right? It goes down the. It goes down. Oh, he's going to try to shoot it. Okay, here we go. We're going to shoot it. Pour it down there with the camera. He's pouring the butane down. I don't see anything. I don't see anything. Is it coming? I can't. Oh, there it comes.
Oh, that was a good one.
That was cool.
Yep. Great demonstration, Jake.
That was a treasure of a demonstration. Do you have any more of that up there?
Right here. Cortland.
We're going to do it one more time. Come on, one more time for the road.
Yep. One more time for the road.
I'm glad we did that.
That's a big
Yeah,
one.
that was a cool last demonstration, Jake.
So hang on a second. Here he goes. You gonna pour it? 3, 2, 1. He pours the invisible gas. Oh, I guess it's all right. Here it comes. Hey, there! It almost burnt the cameraman. That's good.
You
Yep.
good, Cody?
You good? Okay. He's tough.
Good stuff.
Got a couple singed.
Hot air.
Singed the hair there.
Don't do this.
Don't do this at home. That's pretty good,
I
man.
would've had Cody covered, though.
That was really sweet. That's a good demonstration, wasn't it?
Yep, I agree.
So what? To finish this off, what question could I ask a young person to make them ponder what they just saw?
I can smell it, man.
That they just saw this interesting vapor action. What question could I pose? Thank you, Muscle, for hanging on so long.
Number
You're
one
good, man.
commenter.
He's a number one commenter. We'll have to do something about it. That was cool. I saw it. Well, it's something to think about. I've got to come up with a good question. Maybe that you need to be aware that vapors are around us and you just don't want to take it for granted that there's not stuff going on you can't see,
Yeah,
you know?
I'll agree. It's just like you never know with chemicals, like if they're clear, what they are. You know, same thing. Like they're there, and you see. In the case of the liquid, you'll see it, but
Yeah.
you don't know what it is. You know, is it water? Is it hydrochloric
Yeah.
acid? Is it, you know, what is it? What is it made of? You know, and it
Yeah, I don't know.
takes testing to find out. That's
When
why
I
we-
was,
that's what we-
when I was probably 10 or 12 years old, my dad was a fire captain, and my dad never had to spank me much or anything much. Well, he didn't when I was a kid. But the day he got the maddest at me, I mean, he was red-faced mad when he found out what I was doing, that there was a sewer line, that rain sewer, not a sanitary, but a rain sewer that ran under the street for about 8 blocks, and it dumped into a canal. And the kids would play in that pipe because it was 6 foot tall, and we could ride our bikes 6 or 7, 8 blocks underground up the sewer pipe, and you'd turn around and look, and there'd be a circle of light at the end, you know, where it dumped out into a creek. It was just rainwater sewer. And when my dad found out I had been playing in there, he chewed me out, and he said, "Son, you don't understand. I have pulled 2 bodies out of there, out of pipes like that. People go in there, and they don't know there are gases in there they can't see." And you know, those will fill with exhaust fumes that are, you know, and they'll sink into it and fill up, and you don't see the gases until, you don't know it's there until it's too late. And my pop really laid into me on that. He said, "I just, don't you ever go in there again." And I said, "What? What?" I didn't know about vapors and gases. So anyway, that was my story to add to the thing.
All right, Jake. Well, it's been great, great spending time with you.
Hey, it's good hanging around with you, Luna. You're a good man in spite of what we hear.
In spite of what you hear, so true. Have yourself a great night. Rebecca,
Always
have a great
convicted,
night.
never arrested.
Yeah, always convicted, never arrested. He's got it. That's the way it is. Thank you all
It's the way
for
it is.
signing in, and stay in touch. We'll send out another. We're going to do this again here shortly. Whenever we get enough courage to do it again, we'll do another stream.
Yeah, that sounds great.
All right. We'll see you.
Be good.
Thank you, everybody.